everybody, wishing all of you out there a very happy new year. To all my hustlers out there, a very, very, very happy 2025. You know, it's 1st January 2025, and while all other people are busy making resolutions, which they will probably forget in a week or so, you guys are already ahead in the game. How? Because you are sitting here. You have decided to watch this session. You are all focused, all committed, all ready to conquer one of the highest weightage, slightly challenging, but one of the most important and most rewarding units of your mathematics syllabus, which is none other than integral calculus. Yes or no? And this is what I call a kick-ass start to the new year. This is what I call starting 2025 with an absolute purpose. So congratulations. You know, this year, this new year, this 2025, this is like a blank canvas. Understand? Whatever colors you choose will decide the masterpiece that you create. So let's together choose colors of positivity, of a lot of hard work, grinding, of lots of consistency, lots of commitment, lots of discipline, and lots of resilience. And all of this will get integrated to produce a piece, which is what? A beautiful performance and a handsome score and percentile in your JEE Main 2025. And that's what you want, right? So if you are ready, if you are absolutely ready to start 2025, not with resolutions, but with result, with actions, then quickly comment below hashtag JEE2025 is mine. We are going to start this year with lots of motivation, lots of energy, lots of self-belief, and lots of self-love. And all of this will help us manifest our dream, which is JEE 2025. So everybody flood the chat with this hashtag JEE 2025 is mine. And without any further delay, let's quickly dive into our session today, which is on integral calculus. Let's get started with decoding integral calculus, which quite many students are scared of, but today let's decode integral calculus like never before. I promise you people, the questions which I've collected today are very unique, very rich in quality, highly multi-conceptual, and highly fruitful if you practice them diligently. We will of course do a post-mortem of every question, try to learn as much as we can from every question, and this session is going to help you revise your integral calculus perfectly. Okay, so I promise you, stay with me right till the end. If you do so, you will walk out of the session absolutely confident. And any question which comes your way from this unit, you will smash it like a pro, that's a guarantee. So if you are wanting to own integral calculus, to dominate and conquer integral calculus, then stay with me right till the end. Do not forget to hit the like button and also subscribe to this Rankplus JEE English channel because you know why. I don't want you to miss out on even one single session which is being planned for your help, for your benefit. Okay, so if you've liked the session, if you've subscribed to the channel, then quickly grab your pens and notebooks and without any further delay, let's get started. You know, just imagine, before I show you the first question, I want you to just imagine a situation. It just popped up in my head. Just imagine your JEE 2025 is ending. It's like December 31st, 2025, and you are sitting and introspecting. You are, you know, in hindsight, you are looking at 1st January 2025 and you realize on the 1st of this year, I was actually watching integral calculus session and trying to conquer this topic. Yes or no? I was actually working towards achieving my dream. And that will literally make you so proud of yourself. You will want to give a pat on your back. And we want to be in that situation, isn't it? Yes. So if you are here, stay with me till the end because this is going to make you feel a lot proud on yourself. Okay, let's get started everybody. First question on the screen before you. Looks challenging. Yes, it's very dense, full of a lot of digits, a lot of expressions, and it's for you to decode. It's for you to decode. It's for you to decode. Tell me. Quickly tell me. It says the value of this giant expression as limit n tends to infinity has what value? What is the value of this giant expression as n tends to infinity? In this question, I want you to please break down and try to create sections. Try to attack this super lengthy expression into parts. Not attack it wholly, like as one unit. No, break it into parts, small parts, and then attack. See if you're able to decode here. What does it say? Any clue, any guess? I'm going through the chat. Any clue, any guess? Absolutely correct. It's limit as a sum. This question is completely based upon the concept of limit as a sum. Yes, I know this has been formally deleted from your syllabus, but we know as a matter of fact that actually questions from here have been asked even after deleting it from the syllabus. So we are no fools. We have to be ready for every challenge which comes our way. And because there has been evidence in the past that even from topics deleted, questions have been asked in the paper, we are not going to miss out on learning about limit as a sum. And questions are probable to be asked from this topic. So let's master it. In this question, first of all, I want you to focus on what? Just this much expression, then just this much expression, and then just this much expression. So I've broken down my entire expression into sum of 3 distinct series. Let's call this the first one, call this the second one, call this the third one. And how are we going to solve it? Look at the first one. What is it? It's limit n tends to infinity. It's 1 to the power 4 plus 2 to the power 4 and so on till n to the power 4 upon n to the power 5. So it's like summation r to the power 4 upon n to the power 5 from 1 to n. Always keep a check on the variation of the index. R is varying from what to what? What is the lower limit? What is the upper limit? Keep a very strong check on that. Don't take it lightly. Don't take it for granted, because this will determine the limits on my integration. That is why. Okay. Now I know that this kind of looks like the format of limit as a sum. Correct? But I know the shortcut says I should have summation of a function which is a function of r by n. Right? Number 1. Number 2, I should have a 1 by n extra which I convert to dx. And I convert my r by n into x. Then the limit of r gets converted to limit of what? X. And the summation gets converted to integration. These are the 4-step shortcut. Right now, this is not a function of r by n. How can I make it a function of r by n? Also keeping in mind that I want a 1 by n extra, I will write this as n to the power 4 into 1 by n. So now this looks like summation r by n to the power 4, r going from 1 to n, and all of this into 1 by n. Making sense, everyone? Making sense? Now I can very well apply my shortcut. What is it? Replace r by n with x, replace 1 by n with dx, replace your limit of summation with integration, and replace the limits. That means r is varying from where to where? R is varying from 1 to n. So your x will vary from where to where? Tell me. If r varies from 1 to n, r by n varies from 1 by n to n by n. Right? And n tends to infinity. So 0, this is x and this is 1. X will vary from 0 to 1. Is this clear? This is your 4-step shortcut. The 4-step shortcut algorithm to convert your limit of a sum into definite integral. Limit of a sum into definite integral. Is that cool? So what will this get converted to? Everybody quickly. Integration x to the power 4 dx from 0 to 1. Any confusion, anybody? So my first part of the series is sorted. This much part is sorted. No need to integrate right now. You can also, it's your choice. But first part is sorted. Let's go to the second part. First part is sorted. Let's go to the second part. All right. Now what do I have? 1 by root n, then 1 by root n plus 1, 1 by root n plus 2, 1 by root n plus 3 and so on. What is this? 1 by root over n plus 3n. This is something you should understand. This is a slightly hidden part which is giving us the variation of the index r. For example, here I will write this as 1 by root n as it is, and then summation 1 upon root over n plus r going from 1 to 3n. If I wouldn't have decoded that this 4n is actually n plus 3n, I wouldn't have been variation of index from 1 to 3n. Correct? This 1 by root n as it is. This is cool. I have just compressed my series into the summation format, nothing else. Because until and unless I don't compress, I will not be able to actually identify whether this is convertible to definite integral or not, whether it matches the format of limit of a sum or not. Correct? So I have to compress it in the first go in terms of summation. Now you can see I want here function of r by n, and outside I want a 1 by n extra. Now here I only have root n. 1 by root n is there, na? I want one more. I want one more root n, so that root n into root n gives me n. So what will I do? This is root n itself. This is summation. Now just imagine n common 1 plus r by n. Yes or no? I can do this. So 1 by root n summation 1 by root n into root over 1 plus r by n. So 1 by root n I can extract and bring it outside. 1 by root n into 1 by root n gives you 1 by n. Summation 1 by root over 1 plus r by n, r going from 1 to 3n. And now you can definitely say that this is a function of r by n. I have a 1 by n extra and r is varying from 1 to 3n. So what will this get converted to? Everybody tell me. Tell me what will this get converted to? Always remember there is a limit n tends to infinity. I have not written it everywhere, but it's very obvious there is a limit n tends to infinity. So limit n tends to infinity of summation gets converted to integration. If your r is varying from 1 to 3n, that means r by n varies from 1 by n to 3n by n. As n approaches infinity, this approaches to 0 and this approaches to 3. So your x varies from 0 to 3. R by n gets converted to x, so you get 1 upon root over 1 plus x, and your 1 by n gets converted to dx. Enjoying? Enjoying? Just see how a giant expression is now broken down into very easy pieces. Let's quickly attack the third series as well. Okay, here it says limit n tends to infinity 6 upon n plus 2. This is very interesting, and this has a little catch also. And then it says 2 plus 1 by n, 2 plus 2 by n, 2 plus whatever. This is summation 2 plus r by n whole square. Now the problem is r going from 1 to n minus 1. Okay, I have told you already, always check the variation from where to where is the index varying. The limits of the index basically, lower limit, upper limit. Now the problem here is that this is definitely a function of r by n, so I don't want to disturb it. Are you understanding? I don't want to disturb this because it is a function of r by n. The only problem is, where I'm stuck is, I want a 1 by n outside. And there is no 1 by n outside. So what will I do? I am going to pull this expression and I'm going to take out a 1 by n common. If I do that, I will be left with 6 upon 1 plus 2 by n. Not a problem for me. Why is this not a problem for me? Because this will look like limit n tends to infinity. This is 6 upon 1 plus 2 by n into 1 by n, and then there is a summation 2 plus r by n whole square, r going from 1 to n minus 1. Now you would feel that, ma'am, from here to okay, this is expression of my interest. 1 by n will be converted to dx, function of r by n will be function of x, limit of r will give me limit of x, and obviously the summation will turn into integration. But what about this? Bachche, apply your limit here, no? Apply your limit here. This expression is nothing but a constant, because as n approaches infinity, 2 by n approaches 0. So 6 upon 1 gives you 6. You are just left with 6 times limit n tends to infinity, summation 2 plus r by n whole square, r going from 1 to n minus 1, all of this into 1 by n. This is what you are left with. Okay, so this expression that was scaring you in the beginning, this one is just present to give you a 1 by n, because at the cost of that, it will actually convert into a constant. Are you getting my point? And that constant is not disturbing us at all. No, we don't mind having a constant in our life, isn't it? All of us like constants. All of us have friends who are constants for us, isn't it? Who is your constant? Comment below quickly. Who is your constant in life? Comment below. I would love to know that. And now you know the shortcut. Integration. This is 2 plus x whole square. This is dx. And if your r is varying from 1 to n minus 1, r by n will vary from 1 by n to 1 minus 1 by n. As n approaches infinity, this is 0, this is 0. So x goes from 0 to 1. Tell me if this is clear, because we are done with the question. We are done with the question. I am not saying that you will get 3 limit as a sum questions in one question like it happened in this case. But this question gives you a voluminous practice as to, in different formats, how can you get a question based upon limit of a sum. Is that cool? Is that cool? So now you know what is your answer. What is your answer? The first integral was x to the power 4. 0 to 1 x to the power 4 dx. Plus next second one was what? 0 to 3, 1 upon root over 1 plus x. Right? Or root over 1 plus x to the power minus 1 dx. And next was 0 to 1, 2 plus x whole square dx. 6 times. I forgot the 6. Okay? Yes or no? Yes or no? Write it like this only, not a problem. Yes or no? Huh? Let's integrate x to the power 5 upon 5 from 0 to 1. Yes or no? Any confusion till here, everyone? Please tell me right now. Yes? What will this give you? 2 times root over 1 plus x from 0 to 3. And what will this give you? You can even do this. You can treat 2 plus x as t. So dx turns out to be dt. So 6 times integral t square dt, and limit will be what? When x is 0, t is 2. When x is 1, t is 3. You can do like this also. So this part will turn to t cube by 3. There is already a 6 from 2 to 3. So 3 into 2. So you will get 2t cube from 2 to 3. So you are getting 1 by 5 plus 2 times root 4. Root 4 gives you 2 minus 1 plus 2 times you get 3 cube, 27 minus 8. Please check what's your answer. Yes, yes, tell me. 1 by 5 plus 2 minus 1 is 1. So this is 2. This is 54 minus 16. Okay. When you calculate, this is 40. Okay, fine. This is 40. So you get 1 by 5 plus 40. What is your answer? 201 upon 5. Is it 40.2? Is it 40.2, everybody? Quickly tell me. Is it 40.2? It's very simple. There was no compulsion over here to substitute 2 plus x as t. I was just trying to give you an alternate approach as to how you can substitute and make it even easier for yourself. It just helps you getting less errors in the calculation. That's what it helps you with, nothing else. Okay? Okay. Yes, ma'am. No, ma'am. Yes, ma'am. No, ma'am. Cool. Is this question clear? Is this question completely hashtag HDCC, everybody? We have post-mortem the concept of limit of a sum from this question, applied it into 3 different formats type of series. And I hope now this is completely internalized in your system. You know how the concept works. You know how to decode a question and categorize it into limit of a sum. And you know how to apply the 4-step shortcut to convert limit of a sum into a definite integral. And you also know when does a series format actually matches limit of a sum format. When it looks like summation, function of r by n, there is a 1 by n extra. And limit is of n tends to infinity. Correct? This is when a series actually represents limit of a sum. and then you apply the 4-step shortcut to convert it into definite integral. Cool. A very nice, a beautiful question smashed like this. Yes or no? Yes or no? This is how we're going to make everything super duper easy for us. And without any further delay, now let's go to the next question. See, general solution of this differential equation is what? Now, this differential equation is very beautiful. It's very special. It's very, very special. And I want you to brainstorm upon understanding what is the category in which it falls. Can you identify? Can you somehow identify? It says x times y square into e to the power xy plus e to the power x by y dy. And then y e to the power x by y minus y square e to the power xy dx. Okay. Somehow it is confusing because here it's x into y and here it is x upon y. Then here it is x upon y, here it is x into y. It doesn't seem like a homogeneous differential equation to me, no. Throughout I don't have x by y or y by x. No, I don't. This doesn't fit into the template of homogeneous differential equation. Also, it's definitely not variable separable. No, it's not. Also, it's not linear differential equation. No, you can check. Check, is it LDE? Is it LDE? dy by dx plus py equal to q. Is it of that form? Or dx by dy plus px equal to q. Any of the forms. Is it of that form? No, right? I don't think it's homogeneous. I don't think it's fitting in the template of variable separable. I don't think it's even linear. What is it? Yes, you are absolutely bang on correct. It is none other than exact. This is like a devil, okay? Why is this a devil? Because students prepare, and they have in the past prepared very nicely the homogeneous, variable separable and LDE, reducible to homogeneous, reducible to variable separable, reducible to LDE, so nicely they prepared, but actually what entered in the exam was exact. And that was an indirect indication by NTA that even exact is something on which we can test you. So it's high time we make a firm grip, develop a firm grip over exact differential equation and learn how to crack questions of exact very nicely. Okay, look over here. The very first step always is to expand your entire expression, sitting on the left and sitting on the right. So you get xy square e to the power xy plus x e to the power x by y, and there is a dy as well. So okay, dy here plus x e to the power x by y dy here equal to y e to the power x by y dx minus y cube e to the power xy dx. Making sense? Now you collect the like terms. Here there is e to the power xy and here there is e to the power xy. Here there is e to the power x by y, here there is e to the power x by y. So take this there and bring this here. What will I get? E to the power xy common. I will have xy square dy plus y cube dx. And on the right hand side, e to the power x by y common. I will have y dx minus x dy. Now wait a second. I'm sure this would have popped up in your head. When you have y dx minus x dy, this reminds you of second function differentiation of first minus first into differentiation of second upon second whole square. Yes or no? Y dx minus x dy upon y square. This is nothing but d of x by y. How many of you all remember? And can you see partially the format is created on the right hand side? I just need a denominator y square. So what will I do is, from here, let's see if something can be of help. If I take out y square common, I'll be left with e to the power xy. Inside I'll have x dy plus y dx. Wonderful. Wonderful. Can you see this? And on the right hand side, I have e to the power x by y, y dx minus x dy. That's it, bingo. No, let me pull this y square, bring it on the right hand side. It will vanish from here. It will come here. Yes or no? Yes or no? And this completely turns into d of x by y. This is the magic. The moment you open the entire expression up, you start collecting the like terms, you start trying to concise the situation, the expressions, it will start getting converted to differentials, to exact differentials. And that is something you have to decode. Like over here, we were getting y dx minus x dy. It should immediately knock the doors of your memory that this is kind of giving me a hint towards d of x by y. So I need a upon y square over there. Now you go to the left hand side, try to fetch a y square and bring it on the right hand side in the denominator. Making sense, guys? Making sense? So if you have not watched my one shot on differential equations, please go watch it, especially the end part, which is completely based upon exact differential equations and how do you actually approach them and crack them, because there I have explained all the results which you must know at your fingertips related to these exact differentials, d of x by y, d of y by x, and loads of other results as well. If you know them very nicely, very, very nicely, then only you will be able to identify these expressions into what exact differentials they are actually convertible into. Otherwise, it's a struggle. Okay? Otherwise, the same easy question becomes a very tough journey for you, a very uphill task for you, a Herculean task for you actually. Okay? And that is not something that I want. So e to the power xy, what is x dy plus y dx? This is dxy. And here you have ex by y, this is dx by y. This is variable separable now, guys. And you know what is this? E to the power t dt is nothing but e to the power t. Again, e to the power t plus c, and that's your final answer. Such a small, such a nice question. Now here, a and d both are actually the same option. So let's cancel this d out. There is a, okay, yeah, I remember there was a minus here. And that is why this is wrong, this is wrong, this is wrong. A is correct option. So the question just asked you to compute the general solution, and we have the general solution. So is this question clear? Everyone, please comment, quickly chat in the chat, very quickly, very quickly, very quickly. Is this clear? We first of all introspected as to, is it homo? Is it VS? Is it LDE? Because it did not fall into any of these, that's when our head turned towards exact. And then we knew how to proceed for applying the exact method. Open everything up, collect the like terms, and then you will realize and you will find out, and for that you need prior information and prior knowledge about the results and formulas which I'm talking about, so that you can then compress it into exact differentials, which will then convert it into a variable separable, and then you know it's going to be a super duper easy journey for you. Okie dokie. Even this question, hashtag HDCC everyone, correct? The content which I'm providing is very polished, very rich, very unique, and literally unparalleled, unmatched. So please extract the most from this discussion. All right, let's go to the next question, which is this. Fantastic question, fantastic. This is so beautiful. I mean, I love this question. I absolutely love this question. And this is involving a concept which is very favorite to NTA. F and G are inverses of each other. And next it says f of 1 is 3, f of 3 is 1, and there is an integral. And the integrand, if you carefully check, involves f dash of g of x. Can you see this? The integrand is nothing but g of x plus x upon f dash of g of x. It's involving derivative of the composition. Can you see? F dash of g of x is reminding you what? It's reminding you of the differentiation of f o g, which required chain rule to get differentiated and gave you f dash of g of x into g dash x. So f dash of g of x is reminding us, it's kind of giving us a hint of differentiating the fog function. And fog will come into picture. Why? Because f and g are inverses of each other. And if two functions are inverses, their composition is identity. Just see how I am reading the question and trying to get the hint from the question itself. The question itself is shouting out loud and telling me how should I start the question, what approach should I follow, what concepts should I apply. Okay, so it's all about the connection between you and the question, and how minutely and with a lot of detail and closeness are you reading the question with clarity. Okay, if f of a is 2, what is the value of this limit expression where x tends to a? I need to fetch a. Until and unless I have a with me, I can't compute the limit. And for a, I have to compute this integral. So as I told you, because f and g are inverses of each other, fog will be equal to identity. Fog is equal to identity and I'm interested in fog only. Goff is also identity, but I am interested in just fog. So I am going to write f of g of x is equal to I of x, which is x. So f of g of x is equal to x. Now you will differentiate, obviously, as I told you. So f dash g of x into g dash x is equal to 1. So f dash g of x, bache, will turn out to be 1 upon g dash x. Or I can say 1 upon f dash g of x is nothing but g dash x. And this is what will be replaced over here. And that's a very beautiful, magical part of this question. Let's just take a moment's pause to appreciate the beauty of this question. Yeah, it's so beautiful. It's just mind-blowingly beautiful, isn't it? Yes or no? Yes or no? Because now the integral gets converted to 1 to 3 g of x into 1 upon f dash of g of x. And 1 upon f dash of g of x is nothing but g dash x. So this is x times g dash x. All of this dx. This is your a. Now what? Now again, the concept of exact differential. Is this the differential of some expression? Can you tell me? Think hard, brainstorm, guys. Is this exact differential of some expression? G of x into x times g dash x. Huh? Is this exact differential of some expression? Quickly tell me. Come on. Isn't this the derivative of x times g of x? First function differentiation of second plus second differentiation of first. So you basically are getting, yes, did you get it? Good, good, good. 1, 2, 3. This is what? D of x gx. And this actually gives you what? Integration and differentiation are inverses of each other. So you are going to get what? You will just get x gx. Limit from 1 to 3. So you are getting 3 times g of 3 minus 1 times g of 1. What is g of 3? See, when I say f of 1 is 3, that means 1 is f inverse 3. And f inverse is nothing but g. So g of 3 is 1. You get 3 times 1. Here, if 3 is equal to f inverse 1, this simply means g of 1 is 3. So 3 times 1 minus 3 gives you 0. That means a has value 0. Is this cool? Everybody tell me, we are halfway through the question. Is this cool? Everybody in the chat, I want you to be very interactive, highly interactive, because this is a two-way street. I want you to quickly comment in the chat. Is every step clear? Is every step till now absolutely clear? Any confusion, any problem? Because we have computed a. Now I know f of a is 2, which stands for f of 0 is 2. And I want to compute limit of this expression as x tends to a. That means I want to compute it as x tends to 0. As x tends to 0. So let's start. Limit x tends to 0. The question is very, very pretty, very nice, a feel-good question. So let's start. 0 to x. This is what? T times f of x plus x times f of t. All of this dt upon x minus a whole square, which is x minus 0 whole square, which is nothing but x square. Now, right now, if you plug in the value of x as 0, your integral will become from 0 to 0. That means this actually is a 0 by 0 form, which gives you a hint to apply the LH rule. But when you will start differentiating the numerator, you know you will have to apply the Newton-Leibniz rule to differentiate, because one of the limits is x, which is variable, correct? So you will have to apply the Newton-Leibniz rule, but you can't. And this is where majority of the students fail. They don't realize a very minute thing over here, that the integrand involves two variables. And you cannot apply Newton-Leibniz in the case of two variables. Suppose you have 0 to x e to the power x minus t into f of t dt. Right now your integrand involves two variables. You can't, if you want to differentiate this, no, you can't differentiate at this stage. There is x also, t also, but you have to realize the variable of integration is t. These are actually limits of t. So I have to treat x as constant. I have to bring e to the power x outside. Yes, and then consider the rest of the expression. This is what I have to differentiate. Now what I'm going to do is first function, second function. In order to differentiate, I will apply the product rule. First into differentiation of second. When I will perform differentiation of second, I will apply the Leibniz rule plus second into differentiation of first. Is it understood? So whenever there are multiple variables involved in the integrand, you cannot in capital letters apply the Newton-Leibniz rule. Here also there is a t, there is an x. Here also there is a t, there is an x. Am I making sense? So what will happen? You will separate. This is f of x comes outside 0 to x t dt plus again x comes outside 0 to x f of t dt upon x square and obviously there is limit x tends to 0. Are you understanding, bache? Anybody, any doubt, any confusion? I cannot apply Leibniz rule until and unless within my integral I don't have a single variable function. I did not have it here. So even if there is a 0 by 0 situation, at this stage, don't apply Newton-Leibniz. It's drastically incorrect. Okay, it's not a blunder, not a mistake. It's a crime. Don't do that. Don't commit that. My students will definitely not commit that. So let's start. Can I? Because again, this is 0 by 0 form and now I can very well apply the Newton-Leibniz rule. Yes or no? Yes or no? So differentiate. Can I differentiate? First of all, let's integrate this. This is x only, or rather this is t square by 2 from 0 to x. So this will be x square by 2. Let's first simplify. This is x square by 2x square plus this is x. This one I can't integrate because I don't have the information of f with me, upon x square. Tell me if there is any doubt, any confusion. Stop me right now. Yeah, quickly in the chat. Very quickly in the chat. Huh? Very quickly in the chat. This x square cancels out from this 1x. This 1x cancels out. Please tell me. You have f of x upon 2. All right. Plus integral 0 to x f of t dt upon x. Please check this. Please check this. Is this okay? And there is a limit x tends to 0. All right. Now, as limit x tends to 0 over here, you are going to get f of 0 upon 2. And as limit x tends to 0 gets applied here, this gives you a 0 by 0 form, which calls for a beautiful LH rule involving now the Newton-Leibniz rule. You would be thinking, ma'am, when will we apply the Newton-Leibniz rule? Yes, we are getting 0 by 0 situation in all the stages. But in none of the stages, we are applying right now the Newton-Leibniz rule, and you know the reason. Here, we are in perfect situation, in absolute valid situation to apply the Newton-Leibniz rule. So let's differentiate the numerator. You will get what? F of x into differentiation of x, which is 1, and this will be just 1. And there is limit x tends to 0. You know, right? The Newton-Leibniz rule, integrand of upper limit into dash of upper limit minus integrand of lower limit into dash of lower limit. So you will get f of 0 upon 2 plus again f of 0. Yes? So 2 plus 1, 3 by 2 times f of 0. F of 0 is already given to you as 2. So your answer is 3 by 2 times 2, that is 3. Many of you all have got the right answer. Congratulations. It is bang on correct. All right. Let's go now to the next question. I hope this question is crystal clear to you, everybody. If there's any doubt, let me know right now, because the question was damn beautiful. Every little detailing involved to get identified was such a big victory. Every detail that we identified, f and g are inverses, how f dash g of x was reminding us of differentiation of fog, which actually gave us the first step. Yes or no? From where to start the question? Because there is so much diverse data involved, isn't it? Yes? After the replacement of 1 upon f dash g with g dash, we had to compress the integrand into exact differential. Yes or no? After that, we got A, and the journey of computing the limit itself was very beautiful, isn't it? We had to understand that Newton-Leibniz can't be applied when there are multiple variables involved. It just can't be applied. So we segregated the variables, we made the integrand of a single variable t, and then depending upon the need, we have applied the Newton-Leibniz rule in the last stage. The LH rule plus the Newton-Leibniz rule. Making sense? I hope this question is completely hashtag HTCC, everyone. Yes, a beautiful, wonderful question, a feel-good question. Let's now move on to the next one. Waiting for your attention is this one. Again, from the world of differential equations, let this be the solution of the differential equation given here for x positive, satisfying the initial value condition y of pi by 2 is 0. What is the value of y of 5 pi by 2? Okay, fine. What is this differential equation? X y square y dash plus y cube equal to sine x by x, and x is given to be positive. What does this equation remind you of? Any guesses? Any guesses? What does this remind you of? Which type does this fit into? Kind of like a feeling you get, no? When you look at the equation, you kind of get a feeling that, yeah, this looks like homogeneous, yeah, this looks like variable separable, or looks like exact, or looks like linear. What does this look like? Huh? Come on, come on, come on. Come on, come on, come on. Yes? What does it look like? Think, think, think. You will have to think on the D-Day. And if you don't train your mind to think and actually decode what the question is demanding, you won't be able to think on the D-Day also. Train this. We have to train this hard. Okay, and you already know consistency wins over intensity. So every day working upon brainstorming over the questions is what is going to help you. Any one day sitting and brainstorming is immediately not going to increase the stamina and the training of the resilience of your thinking ability. No, it has to be a consistent effort, an everyday effort, and sessions like these always are going to promote that. Okay, this people, somebody has said Bernoulli, absolutely correct. This is, yes, absolutely correct. What is this? This is nothing. This is no new category. This is just reducible to linear differential equation. This is just reducible to linear. Just reducible to linear. All right. And how will you reduce it to linear? Please try to decode. You want dy by dx plus py equal to q. The p and the q are actually functions of x, or they can be constant as well. But you want dy by dx plus py equal to q. Q doesn't have a y involved. Q is just a function of x, or at max it's a constant. It's p into y. So p is a function of x multiplied with y, which is the dependent variable. And you have the differential coefficient, which is dy by dx. So let's start. If I take y cube as t, you will get 3y square dy by dx is equal to dt by dx. Tell me, is this true or not? Is this true or not? So you will get xy square dy by dx. Dy by dx is what? Dy by dx is what? Tell me, no? Huh? What is dy by dx? It is 1 by 3y square dt by dx. This y square cancels out. Yes, ma'am, no, ma'am. Plus y cube. So plus y cube is t equal to sine x by x. This is as it is. So you are getting x by 3 dt by dx plus t equal to sine x by x. What do you want? Instead of y, there is a t. Now, t is the dependent variable. Not a problem. These are all dummy variables only. Don't get confused. So, what you want is dt by dx plus pt equal to q. dt by dx plus pt equal to q. You want the coefficient of dt by dx to be 1. So, you will multiply with 3 by x. 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 So, this gives you 3 sin x by x square. Tell me if this is absolutely clear. Huh, guys? Tell me if this is absolutely clear, because now this is a perfect linear differential equation. Everybody, please take a look. It's like dy by dx plus py equal to q, where p and q are functions of x. Instead of y, we just have a t. Now you know what to do. You will compute the integrating factor, which is e to the power integration of p dx. P is your 3 by x. So what are you getting? E to the power 3 times log x, or rather log mod x to be precise, which gives you what? 3 comes over here in the power of mod x, and you are basically getting mod x whole cube. But there is a very slight piece of information, which is a game changer piece of information, that x is positive. Because x is positive, that is why mod x comes out to be x, and you are eventually getting x cube as your integrating factor. If x would have been given negative, I would have got what? If x is negative, mod x is minus x whole cube would have come out to be minus x. So guys, please understand, do not underestimate the power of restriction given upon x. If there is no restriction, it's fine, treat it as positive. But if there is a restriction given, then you have to adhere to that restriction and accordingly compute the value of integrating factor. Don't take it lightly. Don't rush through this calculation. Always make sure that you are keeping in mind the restriction upon x before deciding the sign when it comes out of the mod. Okay. So this is x cube. So you are getting y into integrating factor is integration of q. Q means 3 sin x upon x square. Integration of q into integrating factor dx plus constant of integration. So y into x cube is equals to 3 times integration of this gets cancelled out, x sin x dx, plus there is a constant of integration. Now you know how will I integrate, right? It's very simple. I am going to apply by parts. Yes or no? ILATE. So this is first function, second function. What will this look like? First function integration of second minus differentiation of first into integration of second, the whole dx plus c. Integration of cos x is nothing but sin x. So that's it. This is plus c. Everyone, have you reached till here? Have you reached till here? Now the initial value condition says y of pi by 2 is 0. That means when x is pi by 2, y is 0. When x is pi by 2, y is 0. Is this making sense? So plug in x as pi by 2, y will come out to be 0. So your complete left hand side will be 0. This is 3 times x is pi by 2. What is cos 90? It is 0. So even this part is 0. Plus what is sin 90? 1 plus c. So you are getting 0 equal to 3 plus c, or c equal to minus 3. Plug it here. Tell me, what are you getting? If c is minus 3, what are you getting on the right hand side? Completely 3 will come out common, and inside you will be left with minus x cos x plus sin x, minus x cos x plus sin x minus 1. Right? There is c is minus 3, no? And left hand side is y into x cube. Yes ma'am, no ma'am? Correct? Now you want y of 5 pi by 2. You want y of 5 pi by 2. So there is y and there is 5 pi by 2 whole cube equal to 3 times minus 5 pi by 2, and then there is cos 5 pi by 2 plus sin 5 pi by 2 minus 1. What is the answer? Can you calculate? Anybody? It's 2 pi plus pi by 2. 2 pi plus pi by 2. So it's same as cos pi by 2, which is 0. Quick. It's 0, na? What about 2 pi plus sine pi by 2? Sine pi by 2 is 1. 1 minus 1, again 0. So this is 0. This is 1. You are getting 0 plus 1 minus 1, which means 0. 0 into 3 is 0. This is 0. Y into anything is 0. That means this quantity is non-zero, pakka se. Yes, this means what? Y is 0. Y into something non-zero is 0, which means y is 0. So y of 5 pi by 2 is coming out to be 0. Isn't this a brilliant question? See, the more neat you keep your work, the entire solution, the less time it's going to take you to reach to the final answer. Students have this belief that if I'm going to write very neatly, very patiently, without messing my work up, I'll keep very legible rough work, very nicely I'll put down the calculations so that it's easy for me to read and understand and actually catch mistakes also in between, then that is going to cost me a lot of time. But actually it won't, because it will save you from redoing the work. It will save you from committing mistakes. It will actually be a big time saver and more mark booster. So please keep your work very neat, your rough work very neat. Don't mess it up. Don't rush too much. And don't try to keep things very cluttered and very jammed together. It's literally not going to help you in identifying your mistakes and going back and identifying where actually did I go wrong, which step have I messed up so that my answer is not coming correct. You won't be able to catch that step. It will be very difficult for you, which will be a big time waster and hence a mark dropper. Cool? Okay? Is this question hashtag HDCC, everybody? Quickly tell me. Very quickly tell me, is this question hashtag HDCC? Yes or no? Differential equation, a very nice question, not from exact, in fact, convertible to linear differential, one of the highest weightage topics in the paper. I don't know why, but JEE Main loves testing you on not just LDE, but convertible to LDE, which is Bernoulli, as you have rightly suggested in the chat. Yes? Can I move ahead? Can I move ahead, everyone? This is a question which will give you a big smile on your face once you are able to decode it. It's such a pretty question and it involves a very important result, but in a very subtle, very indirect manner. What is it? Tell me. Come on, come on, come on. This is not integer, this is integral. By mistake, typing error. This integral is equal to what? Now, this looks pretty fancy, huh? I mean, I'll agree. I'll agree. Yes, I will agree. This looks pretty fancy. The expression looks fancy. The expression looks pretty dreadful as well. But I'm sure that you have it in you to crack this. You have what it takes to identify the approach and to actually crack it. I know you have it in you. Can you think? Again, I'm saying think hard and try to establish patterns and connects. Try to establish some kind of a connect among the expressions given in the integrand and see if you can club something together to make sense out of it. Are you understanding? Everything seems very segregated right now. Yes or no? Very separated right now. Try to club things up, bring some stuff together so that when you club them together, it kind of starts making sense to you and you can understand what the next steps should follow. So tell me. Come on. New year, new energy, guys. It's integral calculus on the plate today. I know you guys want conic sections as well. I know you guys want a probability as well. The next is going to be algebra, where I'll cover very, very wonderful, like super brainstorming questions on probability as well. And we'll prepare probability very nicely, but not just prob. All the topics of algebra will be covered in that algebra one shot. It's kind of going to be like an algebra one shot, like an algebra masterclass, which I will be taking under the series of PYQ marathon. So I have collected tons of questions from across your algebra, from specifically the high weightage topics, the subtopics, which are very promising and bound to appear in your JEE Main. All of that we're going to do in PYQ Marathon, which will cover your probability also, complex numbers also. I keep telling you that please don't leave a chapter completely. At least cover the basics. At least be aware of how to solve questions which come from very repeated concepts, like properties of modulus, properties of argument, properties of conjugate. the properties of cube roots of unity, locus of some very famous curves, like how does a circle look in the complex plane, how is it represented, how is a straight line, a perpendicular bisector represented in the complex plane in terms of z, so that every time you don't waste your precious seconds and minutes and hours in plugging z as x plus iota y and then actually deriving what that curve represents in terms of x and y. Don't do that. So these are some handful of things which you must know from complex numbers. For example, I'm saying. So like that, I have caught hold of some very promising topics and subtopics and concepts and results and the ideas from every chapter of algebra, and I have curated all of that in terms of many wonderful questions which we will do in under the PYQ marathon series. All right, the next is going to be upon that. So probability will be covered there. Please don't worry. Stay assured. And of course, conic sections, vector 3D, all of that is going to be covered after that. Cool? Cool, everyone? Anybody, any clue how to solve this question? I've given you a lot of time. I actually wanted you to decode. Yeah, tell me. If you look at this part. Okay, let me use a different color. If you look at this part, guys, can you identify something? Just this part. If you multiply cos into sine with cosec square, what will you get? Cos into sine into 1 upon sine square. So this will give you cos upon sine, which is cot x. So from here I came here, from here I came here. If you multiply 1 with cosec square x, you will get minus cosec square x, again minus cosec square x, again minus cosec square x. I think some people are moving in the right direction. So eventually you are getting pi by 4 to pi by 2 e to the power x log cos x. This much is cool. But from here to here, your entire expression has compressed or converted into what? Cot x minus cosec square x dx. Guys, is something hitting? Is something striking? Come on, knock the doors of your memory and knock them hard. Come on, knock them hard and tell me, if I bring e to the power x here, I will be getting e to the power x into cot x minus cosec square x. Forget everything else in the world. Do you know the direct answer of this integration? Yes, you do, because we have a very famous, a very popular, highly favorite, very dear of JEE Main. What is it? Integral of e to the power x into f plus f dash dx is nothing but e to the power x into f plus c. Yes or no? When the integrand is nothing but exponential function into a function plus its derivative. A function plus its derivative. I know the derivative of cot is minus cosec square x. So it's like cot x plus minus cosec square x. This is what is the scene. Cot x plus minus cosec square. So your cot is f and your cosec square is f dash. So if at all I have to integrate it, if at all I have to integrate this, my answer will come out to be e to the power x cot x. This is the most fantastic part of this question, everyone. I mean, I just loved it how they have very slyly, very cunningly, they have made us use this result in this question. Because right now I can't integrate directly. No, I have a log cos x sitting in picture, which I need to take care of. So I can't integrate this directly, but I know if at all the case arrives, if at all the situation arrives, I know what is the answer of this integration. So let me now write it in my favor. How it will be favorable to me. This is log cos x. Let's keep it as one entity. And then e to the power x into cot x minus cosec square x as the other entity. And now I am going to apply my bypaths. This is the magic of this question because you know that which function or which part is easy to integrate, you will keep it as the second function. And I know this is easy to integrate. I will keep this as the second. This I'll keep as first. Enjoying? Not a very traditional or a conventional question on bypaths, but this is not fitting into the ILATE model. No, it's not fitting in the ILATE model. Yes or no? It's actually not fitting. If you technically see, it's not fitting. But if you logically see, it is very easily telling you which one to consider first, which one to consider second. Second is easy to integrate because I know its direct answer. So please treat this second bracket as the second function. And now let's apply the bypass. First function into integration of second, which is e to the power x cot x, limit is pi by 4 to pi by 2, minus integration differentiation of first, which is 1 upon cos x, into minus sin x. So this is plus and this is sin x. 1 upon cos x into minus sin x. This will give us what? Tan x. Okay, fine, not a problem. This is tan x. Minus integration of differentiation of first into integration of second, which is e to the power x cot x dx. Now, till here it's very simple because tan and cot cancel with each other, and this integral is very easily solvable. It is e to the power x pi by 4 to pi by 2, which is e to the power pi by 2 minus e to the power pi by 4. So my second integral has been solved. But what about the first part? The first part is a bit tricky, guys, and I know you would have rushed into solving this and committed mistakes already. I know you would have rushed into solving this and committing mistakes already, but this is a tricky part. Let me explain why. Let me explain the trickiness of this part. I will not be rushing. I will never be rushing because mathematics involves very slippery areas in many tricky places. So we have to be careful. I have already told you, devil lies in the details. Devil lies in the details, in those places which are hard to see, hard to capture, hard to notice. That is why you have to be careful at every step, at every stage of your calculation. Here it says log of cos x into e to the power x cot x pi by 4 to pi by 2. Yes ma'am, no ma'am? Now what I need you to do is, you would have realized if x is pi by 2, cos pi by 2 is 0 and log 0 tends to minus infinity. Yes or no? As you approach to 0 from the right hand side, log approaches to minus infinity. So will you get minus infinity here? Tell me. Tell me no. And cot approaches where? Cot is 1 upon tan. As you approach to pi by 2, tan approaches to 1 infinity. So 1 upon infinity will give you 0, so cot will approach to 0. If tan pi by 2 is infinity, cot pi by 2 will be 0, na? So 0 into e to the power x will be 0. So this is minus infinity, this is tending to 0. This part is tending to minus infinity, this is tending to 0. What will the overall limit be? That's why this is a tricky part, and that is why you need to understand what you need to do to eventually reach the right answer. Did you understand? One part is leading to minus infinity, another one is approaching to 0. So the product will reach where? Generally the conclusion is 0, but understand how. Understand how. See, break this up. Write this as log cos x into e to the power x, and this is cos x upon sin x. So write cos x here and write 1 upon sin x here deliberately. I'll tell you why, and after this you will never forget in your life. See, as x approaches pi by 2, as x approaches pi by 2, I'm talking about the upper limit right now. When you plug in the upper limit in place of x, what happens? See, you can write this as cos x log cos x e to the power x when x is pi by 2 minus cos x log cos x into e to the power x when x is pi by 4. So this part is when you've plugged in the upper limit minus the lower limit. Okay, when you plug in, and this is upon sin x. This is also upon sin x. When x tends to pi by 2, sin 90 tends to 1. This tends to 1. This tends to e to the power pi by 2, which is a positive constant. So this much part is gone. E to the power pi by 2 upon 1 is just a constant. What about cos x into log cos x, guys? If you consider x log x as x tends to 0, just consider x log x as x tends to 0. What is this? This is limit x tends to 0 from the right hand side, because log is defined only for positive real axis. This will give you log x upon 1 by x. I can alternatively write it like this. So you will get limit x tends to 0 from the positive. Apply the LH rule because it's 0 by 0 form. So you will get 1 by x upon minus 1 by x square, which will eventually give you what? X square upon x with a minus sign corresponding to x0. Your answer will come out to be 0. This is a superstar concept. X log x when x tends to 0 from the right hand side is 0. And that is why cos x into log cos x when cos x tends to 0 is again 0. So here you have x tends to pi by 2. When x tends to pi by 2, cos x tends to 0. So cos x into log cos x will obviously have limit as 0. That is why this expression is approaching to 0. Is that making sense? So 0 into e to the power pi by 2 will simply be 0 minus, what is this? Cos pi by 4, which is 1 by root 2. Sin pi by 4 is 1 by root 2. 1 by root 2, 1 by root 2 cancels out. Right? Cos pi by 4, 1 by root 2, you will get log of 1 by root 2 into e to the power 1 by root 2. E to the power pi by 4, not 1 by root 2, e to the power pi by 4. Is this making sense, everyone? So you eventually are getting minus log of, this is what, 2 to the power minus 1 by 2. And this is e to the power pi by 4. Yes or no? Yes or no? So what are you getting? Minus 1 by 2 comes before, you will eventually get 1 by 2 log 2 e to the power pi by 4. See, 1 by 2 log 2 e to the power pi by 4. This minus 1 by 2 comes aage, comes before, and minus minus gives you plus. Okay? Cool. So eventually what is your answer? For this tricky part, it is 1 by 2 log 2 e to the power pi by 4 plus, this is the remaining answer, which is e to the power pi by 2 minus e to the power pi by 4. Please tell me if this is absolutely clear to you. Yes, ma'am? No, ma'am? E to the power pi by 4 you can take out common. You will have 1 by 2 log 2 minus 1 plus e to the power pi by 4. And this is your answer, everybody. Trumpets and drums. Popo! Trumpets and drums. Did you enjoy? Did you enjoy? Because I had super duper fun, yeah. Such a nice question. Such a nice question. I mean, literally, yaar. I mean, questions like these literally deserve a round of applause because yes, they do lay some amount of challenge in front of you. I'm not denying. But that is a dignified challenge, a respectful challenge, isn't it? It's not like a bouncer challenge. Something which just doesn't strike. No, this is within our range. Within our range, isn't it? All we wanted to do or all we were supposed to do was club this and realize that it's cot x minus cos x square, where differentiation of cot is minus cos x square, and that should have immediately rung the bells of this result. The moment you recognize that this is the result which is getting activated over here, it's very easy for you to, in the next step, apply bypaths in this manner. And after that, it's just applying the upper limit and the lower limit, which requires some analysis, which I've given you over here. That requires a little analysis. The tricky part requires analysis because applying the lower limit did not require that much analysis. Applying the upper limit pi by 2 required analysis because things were tending to 0 and hence the behavior was supposed to be precise. It was supposed to be studied. You can't just directly say minus something is tending to minus infinity, something is tending to 0, so product will tend to 0. Many times, mostly this is what happens, but you have to understand the justification as well, which I hope is absolutely clear. Is it absolutely clear? Is it hashtag HDCC, guys? Completely clear. No iota of doubt is allowed. No iota of doubt is allowed. Is this hashtag HDCC? Yes or no? Quickly comment in the chat. Yes, ma'am. No, ma'am. Correct? Alrighty. A is the right answer. Let's go. Come to the next question. Now, every question is such a lovely question because I have literally invested my, not just time, but a lot of intention, a lot of purity into selecting the questions which can actually benefit you. I have not just come with random set of questions running behind the number of questions. No. Of course, we are solving a lot of questions. I will be solving it today. And of course, some bunch I will be giving you for homework as well. But keeping that aside, what is even more important, one level up important to amp up your game is that you solve the right set of questions with the right mindset. Okay? Okay? So, let's start. F is a function from close 0, pi to r defined in this piecewise manner, what is the value of integral of f? Now, why do I have a smile on my face? Because this question, in this question, students commit an error, which is a very common error. Can you identify what that error is? Come on. Can you identify what that error is? Tell me. Huh? It's a very easy question, trust me. It's a supremely easy question. You can crack it in a minute. If you understand the right approach to attack it, you can crack it in a minute. Not lying. Not lying at all. You know what is this? What does this demand from you? It says integral 0 to pi f of x. 0 to pi f of x, but f of x has two definitions. One in 0 to pi by 2, another one in pi by 2 to pi. So it's but obvious that you will break your interval at pi by 2. This is 0 to pi by 2. What is f of x? X minus pi e to the power sine x dx. And then there is pi by 2 to pi, x into e to the power sine x plus 4 by pi dx. I have to compute its value. I have to compute its value. If you start integrating both these integrals individually, that is not going to be the right approach, guys. Integrating each of these is not the right idea over here. No. You just have to convert one in terms of the other so that there is a relationship from which we can benefit. In questions like these, remember, they are very, very easy. All they want to test you upon is not your integration skills quite literally, but they want to test you upon the establishment of relationship between different integrals to compress them and kind of boil them down, narrow them down into something very easy to deal with. That is what they're testing you upon. That is exactly what they're testing you upon. Is that making sense? So what am I going to do is I'm going to play very smart, and you'll realize that I'm going to play very smart. How? This is 0 to pi by 2. I somehow wish to convert 0 to pi by 2 to pi by 2 to pi. In order to do that, obviously I will involve some substitution because my aim is to convert this integral into this. Somewhat, to establish a relationship between these two, and for that the first step is to match the limits of integration. So from 0 to pi by 2, if I want to take it to pi by 2 to pi, I would need some substitution. A perfect substitution for that, will it be take x minus pi as t? It will give you dx equal to dt, but when x is 0, t will be minus pi. When x is pi by 2, t will be minus pi by 2. No, that will not work. Instead, let me take pi minus x as t. So minus dx will be dt. X minus pi equal to t is not working well for me. Minus dx is coming out to be dt with this substitution. So you will get what? This is minus x minus pi is pi minus x is t. Na? So this is minus t. E to the power sine x is replaced with pi minus t, and dx is actually minus dt. When x is 0, t is pi. When x is pi by 2, t is pi by 2. Okay? This minus cancels out. Sine of pi minus theta is same as sine theta. So this is sine t itself. So basically your first integral has converted to this. So eventually what are you getting? This turns out to be pi to pi by 2. And then I have t e to the power sine t dt. Correct? Correct? T e to the power sine t dt. This is your first converted integral. The next was pi by 2 to pi. So plus integral pi by 2 to pi, you have x e to the power sine x dx plus integral pi by 2 to pi 4 by pi dx. I have separated this also. This 2 part, no? I have separated it into 2 integrals. Correct? And now you can see, you know the property of change of limits, isn't it? Integral a to b is nothing but minus integral b to a. Integral a to b of some integrand is it equal to minus of integral b to a for the same integrand. So this is what? Minus of pi by 2 to pi. It was pi to pi by 2, which is minus of pi by 2 to pi. And that is why both of this get cancelled. You never ever had to integrate actually. You were not supposed to integrate, Baba. All you have to integrate is this. Okay, this is what? 4 by pi. This is pi minus pi by 2, which gives you 4 by pi into pi by 2. Pi cancels out. 2 is your final answer. Can you check this? Such a wonderful question. And this is a very easy question. I hope you understood how have I actually manipulated the expression by applying a substitution technique. That too I have brainstormed upon it. I wanted to, in the first go, very naturally, very instinctively, my reflex came out to be taking x minus pi as t. But that actually didn't serve the purpose. Right? So I took pi minus x as t because x minus pi equal to t was giving me an extra minus sign. So to get rid of it, I took ulta. I took the opposite as t, which is pi minus x as t. And that actually made my process very smooth. My integrals were cancelled out, which most of the times happens in such questions. And I was left with a very easy calculation getting 2 as my answer. Have a smile on your face. Have a smile on your face because that is like a reward which you give to yourself when you get a question right. You know, when you have a smile on your face at the end of a question, that actually implies that somewhere you are silently giving a pat on your back and your inner child gets very happy. Somehow the energy increases, there are good hormones flushing through the body and you are more focused in a very nice feel-good state, even more charged up and pumped up to attack the further questions with a clearer mindset and better stability and composure. Okay? So don't forget to smile when you are able to solve a question, when you get it right, when you understand the approach and you're like, I know it. This is very important. Okay? All right. Hashtag HDCC for this question as well in the chat very quickly, everyone. Without a hashtag HDCC, we are not going to move ahead. Is this also clear? Everyone watching right now, hashtag HDCC for this question. Let's see what the next question looks like. Oh, this is something fab. Because this is not regular. This is a very irregular category. Not regular, very honestly. This is a pretty irregular category. This is reminding you of something which is not directly given over here, but indirectly is getting involved. What is it? Tell me. What is it? Do you know this? Answer. Yes. What is this reminding you of? The question says f from R to R is a differentiable function such that f dash is greater than 2 times f. It says f dash is greater than 2 times f for all x in R and f of 0 is 1. What about the options? F is increasing, f is decreasing. F is greater than e to the power 2x or less than e to the power 2x. Very nice question. Very nice question. And let me tell you, this is a JEE Advanced inspired question. Yes, people, bound to get in JEE Main as per the level up of the paper. Bound to get. Understand how is this a very unique and a different category of question. And why, when this question came in JEE Advanced, most students were unable to do it. See, what does it look like? F dash x is greater than 2 times f of x, right? This is what it looks like. This means dy by dx minus 2y is greater than 0. Baba, look at this, no? This is what it looks like, no? dy by dx minus 2y is greater than 0. Yes or no? Your y is nothing but f of x only. That's how you represent. Now, what is this reminding you of? dy by dx plus py equal to q. If there was an equal to q, I would have declared it as a linear differential equation. But this is dy by dx plus py, that's it. No equal to q. So this is not a linear differential equation. This is a linear differential, inequation or inequality. Linear differential inequation or linear differential inequality, wherein your p of x is nothing but -2. dy by dx plus py equal to q. There is no equal to q, there is a greater than 0, right? There is no q involved. I just have my p, and the good news is to compute the integrating factor, you only need p. You will have to compute the integrating factor now, which is e to the power integration of p dx, e to the power integration of -2 dx, which is e to the power -2x. Please check this out. The moment you have your integrating factor, now comes the trick. Trick to solve a linear differential inequation. The trick says to multiply integrating factor both sides of the inequality. Multiply the integrating factor both sides of the original inequality, this one. So what will you get as the result? What will you get as a result? You will get dy by dx into e to the power -2x minus 2y into e to the power -2x greater than 0 into e to the power -2x is 0. So I've multiplied my e to the power -2x to both sides of my inequality. This is what I'm getting. And now comes the catch. The catch is to convert my left hand side into exact differential. Compress it into the differential of some expression. Compress the entire left hand side and tell me what is the differential. Which expression's differentiation is this left hand side? Quick. Who will tell me? Think, guys. It's not that difficult. It's not that difficult. Think. dy by dx into e to the power -2x minus 2y to the power -2x. Not that challenging. Yes, absolutely. This is what? D by dx of y into e to the power -2x is positive. Isn't it? This is what it says, no? First function, y, into differentiation of second, which gives you e to the power -2x into -2. It is this part. Plus second function, differentiation of the first, which is this part. So basically, exact differential of y into integrating factor is what is your left hand side. What is this? This is y into integrating factor only. Na? So generally, whenever you will multiply the integrating factor to both sides of your inequality, eventually your left hand side will get converted to what? D by dx of y into integrating factor. Generally, this is what happens. So you can remember it as a result as well, remember it as a fact as well, but you can also kind of double check as to, yeah, this is actually getting valid or not, holding valid or not. Here I have checked y into integrating factor is actually getting differentiated to give me the above expression, my left hand side. Right? Now it's time for some magic. If you treat this function as g of x, you are getting g dash is positive, which implies g is a strictly increasing function. Oh, but I don't want to comment upon g. My options actually said that comment upon f. Can you see this? My options want me to comment upon f. If g is a strictly increasing function, let's plot the graph of g. Let's plot the graph of g, everybody. See, g of x is f of x into e to the power -2x. What is g of 0? It is f of 0 into e to the power 0. F of 0 I know is given to be 1. So this is 1 into 1, which is 1. So g of 0 is actually 1. I want to only comment upon open 0, infinity. Now look at the options. The options are only talking about the positive real axis. So I only want to talk about the graph of g corresponding to the positive real axis. Positive x-axis basically, correct? So corresponding to 0, my answer is 1. After that, my g is strictly increasing. This is my g, can you see it? This is my g, this is the graph of g. And what can you see? If at 0 it's 1 and after that it's strictly increasing, that means g of x is greater than 1 for all x positive. The moment you go beyond 0, the value will be greater than 1. Because it's strictly increasing function, so at 0 it will give you the minimum value, and after that it will be, everything will be greater than 1 for sure. Is this understood? At 0 it's 1, after that it's strictly increasing, like we have derived, we've proved. So g of x is greater than 1 for all x positive. G of x greater than 1 means what? F of x into e to the power minus 2x is greater than 1, or f of x is greater than e to the power 2x for all x positive. It's greater. F of x is greater than e to the power 2x, not lesser. Another thing given in option A and B is that f is increasing, f is decreasing. How will you comment upon that? How will you comment upon that? Tell me. See, when you say f of x is greater than e to the power 2x for all x positive, you know as a matter of fact that exponential is a strictly positive function. Exponential is a strictly positive function. That means from here you are getting that even f is positive. But your question said that f dash is greater than 2 times f, and f is positive, so 2 times f is positive. This gives you f dash is positive. For all x positive, f dash is positive, which means f is strictly increasing in 0, infinity. Yes, ma'am. No, ma'am. You like the way I proved f is strictly increasing? Did you like the way? Did you like the way? We had f greater than e or e to the power 2x, which is fine. But writing this that e to the power 2x is positive and hence implying that f is positive. And then using our original differential inequality that f dash is greater than 2f implies f dash is positive. Because f is positive. Yes? And that is why f is strictly increasing. Such a wonderful question, isn't it? I told you it's a very unique question, but a very, very rich question in terms of learning, in terms of representing a different category. So linear differential equation is something which is obviously, you know, is important, but linear differential in equation, which is questions like these, is also very important. From this you have to, you don't get actual f in picture. Can you see this? You have a linear differential inequation of f, but when you're solving it, you are not getting f. Actual definition of f you are not getting, but somehow you have to analyze the scene and comment upon f being increasing, f being greater than this, lesser than this, whatever. Whatever judgment about f the question is demanding, that you have to make without having actual definition of f with you. Because you're not getting what f looks like. Indirectly, you have tried to find out what are the features of f. It's strictly increasing, it's greater than e to the power 2. So that's why this question becomes very, very important, and it represents a category by itself. Whenever we do linear differential equations, we solve them to get our function, actually our function. The initial value condition gives us the value of c and we get our actual function. After that, commenting about anything on that function is very easy. You have the function with you, you can differentiate, you can integrate, you can compute the value of it at a certain input, you can do whatnot. But in such questions, when you have a linear differential in equation, you don't actually get your function f. But somehow you have to use the analysis around it like we did in this question to judge its behavior. The increasing, decreasing behavior, the greater than, less than behavior. You will have to analyze the world around it. All right? Like the question? Wonderful question, right? A very nice question. I mean, I absolutely love this question, and I hope you have liked it too. Everybody very quickly comment, is this question hashtag HDCC, because we are starting with the next one. Is this hashtag HDCC? This was multi-correct. First and third options were right. Is that cool? I'll move ahead. F of x is given to you as 1 plus x square, and then there is an expression, number of solutions of f of x equal to 1. This is a nice question. Tell me. Pretty nice question. F is a function from R to R. F of x is given to you as 1 plus x square, 1 plus this integral, number of solutions of f of x equal to 1. Now, until and unless I have my f with me, I can't plot the graph of f. I can't plot the graph of f, and I can't plot the graph of 1 together in one Cartesian plane and then check how many points are they intersecting at, and that will give me the number of solutions. When you say number of solutions of f equal to g, what does it mean geometrically, graphically? You plot the graph of f and g in the single Cartesian plane, same Cartesian plane, and you catch hold of their intersection points. As many as there are points of intersection, those many are number of solutions of f equal to g. So I should have the graph of f with me, no? Then only f equal to 1 I will be able to check for number of solutions. But what is f? In order to compute f, I will have to decode this. Yes or no? And the problem here is that f is actually sitting inside an integral. If you carefully observe the expression, your f is sitting within an integral. To extract it out of the integral, to keep it independent of the integral, I will have to differentiate. Because what is the counter of integral? The anti of integral. It's differentiate. No, then only the integral sign will get cancelled out and I will have my f in an isolated manner. Right? Yes? Okay? That is why we will differentiate both sides. That is why we will differentiate both sides. What are you getting, people? You will get f dash x equal to, tell me, or you can do one more thing. Let me write this as f of x upon 1 plus x square. So that individually you have just your integral on the right hand side, because differentiation of 1 is also 0. So it's more like just your integral is there on the right hand side. No trouble at all. Just your integral there on the right hand side. Directly you can differentiate and release your f. Release and free your f. So everything I've pushed to the left hand side. Let me now differentiate. Now I'm going to differentiate. Now differentiate, you will get what? Second function. Differentiation of first minus first into differentiation of second upon second whole square. Right hand side, differentiation of 1 is 0. After that, I will obviously apply what? My Newton-Leibniz rule, which I am allowed to apply because my integrand is the function of a single variable t. So I can straight away directly apply. I will get what? F of x upon 1 plus x square into differentiation of x is 1 minus f of 0 upon 1 into 0 ka differentiation is 0 only. So no need to write the subtraction part. This is what you get. So 1 plus x square cancels out. What are you left with? Tell me. 1 plus x square into f dash x. Very nicely you have to solve this question, okay? Minus f of x into 2 of x. Not 2 of x, 2 into x. Upon 1 plus x square equal to just f of x. What do you think this is turning into? Tell me, what do you think this is turning into? Huh? Because you can separate, no? See, you can separate. You will get f dash x minus f of x into 2x upon 1 plus x square equal to f of x. Isn't it? Because this much part you segregated, so your 1 plus x square cancelled out. Right? You're just separating the denominator and putting it below each of the expression of the numerator. Okay, what next? Is it somehow getting converted to a differential equation? I want you all to please tell me. Huh? Because you will get f dash x equal to f of x common. You have 2x upon 1 plus x square plus 1. Huh? Which will give you f dash upon f equal to 2x upon 1 plus x square plus 1 dx. Because f dash upon f is what? It's like what? Come on. F dash upon f. Can you integrate? F dash upon f equal to integration of what? 2x upon 1 plus x square plus 1. What is f dash upon f? It's like dt upon t or dx upon x, which is log x. So this will give you log of f of x. Here what will you get? 1 plus x square you plug in as t, you get 2x dx is dt. So dt upon t, again log t, t is 1 plus x square plus x plus c. Tell me if this is not clear, if to stop me right now. Yes? Yes, ma'am? If this is your solution, how will you compute c? Because till the time you don't compute c, you are not going to get closer to f. And you don't forget your destination, don't forget your actual purpose or actual goal. It is to compute f. So I want my c. I want this unknown c's value. Where is my initial value condition? Huh? Yes? I have already told this to you when we were solving questions in our one-shot sessions. In such questions, guys, you don't get directly an initial value condition. It is hidden and you have to find it out. It's hidden. You have to search for it. You have to fetch it. You have to dig deep in the expression and you will realize it's right there. It's right there. It's right there. Where is it? It is here. When you have integral 0 to x, whenever you have such an expression, you always plug in x to be that value which matches the lower and the upper limit and makes my integral vanish. Right now you have integral 0 to x, so you will take x as 0 so that your integral becomes 0 to 0 and it actually vanishes, the value is 0. If the integral was having limits as 1 to x, then you would have taken x as 1, the integral would have become 1 to 1, again the value is 0. If it was minus 2 to x, then you would have taken x as minus 2, so that integral becomes minus 2 to minus 2 and eventually its value is 0. This is how you get your initial value condition in questions like these. These questions don't come with an initial value condition. It's hidden. It's hidden there, and finding it is a journey which I just told you. So here what am I going to do is I am going to plug in x as 0. I will get f of 0. 1 plus 0 square is 1 into 1 plus 0. Because 0 to 0 integral will be 0. So f of 0 is actually 1. This is your initial value condition which you have found out. A very important step, everybody. Very important step. Many students get confused as to how to proceed from this stage, how to get the value of c. So I've told you, you are not supposed to forget it ever, ever, ever. Cool? Cool? Okay. Now, if f of 0 is 1, f of 0 is 1, log 1 is 0, x is what? 0, log 1 is again 0, plus x is what? 1, plus, x is 0, plus c. So c is 0, basically c is coming out to be 0. Fine, not a problem. You get log of f of x equal to log of 1 plus x square plus x plus 0. Now, if everything is in terms of log, let me write this x also in terms of log, which is log of e to the power x, not a problem. So you get log of f of x, log m plus log n is log of m into n. So e to the power x into 1 plus x square. You basically get f of x, bingo guys, e to the power x into 1 plus x square. This is your final function. This is your final function. F of x is equal to e to the power x into 1 plus x square. Okay? Did you understand the entire journey that we underwent? We had to undergo to reach the final definition of f. Yes, appreciated. So the moment I have f of x is equals to e to the power x into 1 plus x square, now you can shoot any question at me about f, I will be able to tell you. Ask me where it's increasing, ask me where it's decreasing, ask me what are the number of solutions of f of x equal to 1, ask me the graph, ask me what you want to. I will be able to at least proceed with the solution of that because now I have my f with me. And I will be able to get the value, the answers also because now I have my f with me. Okay? Okay? So, f of x equal to 1. F of x equal to 1 means what? E to the power x into 1 plus x square equal to 1. That means 1 plus x square equal to e to the power minus x. Now you treat this as g of x and you treat this as h of x. You want the number of solutions of this equation. It's equivalent. No, it's equivalent. Number of solutions of f of x equal to 1 is same as number of solutions of g of x equal to h of x. And for that, I will have to draw the graph of both these curves. So let's start. E to the power minus x looks like this. Very good, very good. This is e to the power minus x. This value is certainly 1. What about 1 plus x square? 1 plus x square is an upward opening parabola whose vertex is at 0, 1. Now, understand the parabola will go like this Or you feel the parabola will go like this? Please tell me. It's an upward opening parabola, no? Either it can be the white one or the blue one. Yes or no? It can be above the exponential graph or below the exponential graph. But actually there is no confusion. It's very simple that when you plug in x as, let's say, -1, because the confusion is only on the negative x-axis. Positive x-axis pe to you know, na, it will be above than exponential graph only. What about the negative x-axis? If you plug in x as -1, you will get 1 plus 1, that is 2 on the left hand side, and e to the power 1 on the right hand side, exponential, the exponent e, the Euler number is sandwiched between 2 and 3. It's greater than 2. If you plug in x as -2, you will get 2 square, 4 plus 1, 5. And here you'll get e to the power minus of -2, which means e square, which is a number even greater. Yes or no? That means corresponding to every negative input, exponential e to the power -x is giving you a greater answer than 1 plus x square. So actually your graph will not be the blue one, it will be the white one. It will be this white one. Okay, it will be this white one, because corresponding to every negative input, e to the power -x will be way greater in value than 1 plus x square. Obviously, the differentiation of 1 plus x square is 2x, but the differentiation of e to the power -x is minus e to the power -x. It's way stronger. The rate of change is way stronger of e to the power -x than of 1 plus x square. So it will obviously be above. I hope you've understood. Yes, you can plug in some values and also check. If intuitively you're able to feel that, then also you can draw it the right way. Is this clear? A very small doubt which can occur, that your parabola will lie below exponential or above exponential on the negative x-axis. So I've explained that to you. I hope it's crystal clear now. Yes. So how many solutions are there of both these curves? This is 1 plus x square. At how many points are these two graphs intersecting? At only one point, which is 0, 1. So there exists only one solution. Okay, so the answer to this question is 1. The number of solutions of f of x equals 1 is 1. Isn't this a brilliant question? Brilliant, fantastic, fantabulous question. Huh? Yes or no? How have we right in the beginning decoded that until and unless we differentiate, we can't release f from the integral, and till the time we don't have explicit individual definition of f, I can't actually move ahead and compute the number of solutions of f equal to 1. I can't. I need f in picture. In order to comment upon the behavior of f in any manner, increasing here, decreasing here, what is the value, what are the number of solutions, whatever way I want to comment upon the behavior of f, for that I should have my f. And that is what gave me a hint to differentiate both sides. But because I wanted to isolate f, I wanted to individually find f, I brought 1 plus x square to the left hand side, so that I only have this much part which on differentiating will release my f from the integrand. This was also a very smart step, that we brought our 1 plus x square to the left hand side, and then of course it was a very smooth sail. The question was a very smooth sail, a very easy differential equation, variable separable, and then you knew how to decode the initial value condition, a very important step, as I told you. Don't forget. Cool? Cool, people? Again, hashtag HDCC, everybody, any doubt, any problem, stop me right now. Is this cool? Is this cool? Did you like the question? Yes? Feeling confident already? Very good, very, very good. I have some wonderful questions still waiting for your attention. So, be patient. I is integral from 2 to 3. This is a beautiful question. This is a very, very, I should say, a new type of a question which will test you on new concepts and new ideologies and new approaches. So it says integral 2 to 3 x minus 1 whole cube plus 4 minus x whole cube plus x, all of this into cos pi x. What is the value of I into pi square? Foo-foo. What do you think you'll do? What do you think you'll do? Tell me, tell me, tell me. Come on, come on, come on. No, 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 no. Don't even try to open the brackets up and then integrate separately. Don't do that. Please, anybody who's thinking upon these lines, that open the braces and integrate separately. Wrong, super wrong approach. My students will not do this. Supremely wrong approach. Guys, come on. Think hard. Think smart. Quick. You have your eye with you. What should you do? The eye is very much suggesting, the framework of I, the integrand which is sitting over here is very much suggesting what to do. Can you see? X minus 1, 4 minus x. Remember a plus b minus x. That is what should strike your head when you look at these expressions. What is it? A plus b minus x. It's nothing but the king's rule. So I is given to you 2 to 3. This is x minus 1 whole cube plus 4 minus x whole cube plus x into cos pi x dx. You apply your king's rule and you get another time I from 2 to 3. 2 plus 3 minus x, which is 5 minus x. So when you replace x with 5 minus x, what happens? X minus 1 becomes what? X minus 1 becomes what? 5 minus x minus 1. So it is 4 minus x. 4 minus x whole cube. Then you have what? 4 minus x. 4 minus x becomes what? 4 minus 5 plus x. So this is x minus 1. This is x minus 1 whole cube. And x gets replaced with 5 minus x. All of this into cos pi x dx. Now just check. If you will compute 2i, what will you get? Integral 2 to 3. You're subtracting or you're adding. You're adding, right? What will you get? Come on. What will you get? Tell me, tell me. Oh, this I have written wrong. Okay, okay. This is pi and inside you will have 5 minus x. So this will give you 5 pi minus 5x. Okay, this will give you 5 pi minus 5x dx. Okay, okay. But what is 5 pi minus 5x? Pi into 5 minus x, right? Pi into 5 minus x. This is pi x. What is 5 pi minus theta? Cos of 5 pi minus theta. 5 pi, just imagine pi, 2 pi, one cycle, 3 pi, 4 pi, another cycle, 5 pi. 5 pi minus something will bring you in the second quadrant. In the second quadrant, this is odd integral multiple of pi minus theta, right? 5 pi. So what will you get? Tell me, no? It's not multiple of pi by 2, it's multiple of pi. So you will get cos of pi x, but with a minus sign because cos is negative in the second quadrant. So this actually turns out to what? Minus cos pi x. So what happens? This minus sign, because of this minus sign, please understand, it's like there is a minus sign here, there is a minus sign here, and there is a minus sign here. And that is why when you are adding, what happens? This and this gets cancelled out, this and this gets cancelled out. All you are left with is x minus 5 plus x. So 2x minus 5. Please check. 2x minus 5 is what you are getting. 2x minus 5 is what you are getting into cos pi x dx. Please check, everybody. Because you have minus cos pi x here, because of this minus sign, actually you are getting minus in all these expressions because there is bracket. You are actually multiplying the minus sign inside the bracket in each term, and on adding things get cancelled out. Okay, things are getting cancelled out. This is what you are getting. Yes ma'am, no ma'am? Yes. Now what can you do at this stage itself? At this stage itself, what can you do is you can apply by parts. Not a problem at all. Some people are saying you can apply by parts, or you can apply a master stroke? What is a master stroke? See, what do you have? 2i equal to 2 to 3, 2x minus 5, cos pi x dx. Learn the master stroke. It will not just help you to crack this question easily, but many questions of integral calculus very easily. So you have 2i here. From the right hand side, extract out 2. You get x minus 5 by 2. And then you have cos pi x and then 2 to 3. So this 2 cancels out. Now I want you to perform a substitution. What is the substitution? Anybody? If I take x minus 5 by 2 as t, just keep listening, you will get dx is equal to dt. And what will your limit change to? 2 minus 5 by 2, which gives you 4 minus 5 minus 1 by 2. And 3 minus 5 by 2 gives you 1 by 2. This is the magic, guys. When your limits change to minus a to a. The moment your limits look like minus a to a, you immediately have the even odd property popping up in your head. Like lightning fire, isn't it? With the speed of light, what should hit your head? Your memory? Your presence of mind? Even odd property. Minus a to a, if the function is odd, integral answer is 0. Minus a to a, if the integrand is even, it is 2 times integral 0 to a. This should hit your head with the lightning speed. And this is what the master stroke does. So here you have t and then you have cos pi. What is x? X is t plus 5 by 2. This is pi t plus 5 pi by 2. Yes or no? This is like 5 pi by 2 plus pi t. Yes or no? And this is your I. And this is dt. So pi by 2, pi, 3 pi by 2, 2 pi. Then 5 pi by 2 plus something. This will give you sine pi t but with a negative sign. Minus sine pi t. How many of you all understand? Pi by 2, right? Positive y-axis. Pi by 2, pi, 3 pi by 2 negative y-axis, 2 pi, 5 pi by 2 again positive y-axis, plus something takes you in the second quadrant. Cos is negative in the second quadrant, but here we have multiple of pi by 2, so cos will change to sine, minus sine pi t. This will give you minus 1 by 2, 1 by 2, t into minus sine pi t. There is a minus sign, dt. This is your I, everybody. This is your I. This is your I. And why is this a master stroke? I have a very wide smile on my face because what kind of a function is this? This is odd. This is odd. Product is even. Yes or no? If this is even, you will get 2 times integral 0 to 1 by 2 t into sine t dt. And that's it. That's it. This question has actually technically come to an end because now you only need to apply bypaths to this much part, which is a very easy business. This is pi t. Yes. It is a very easy business, guys. It's a very easy business. ILATE, you know. Yes. So you have minus 2 as it is. First function, integration of second, you will get minus cos pi t upon pi. Right? Limits are from 0 to 1 by 2. First function, integration of second, minus differentiation of first into integration of second dt. Please check this out. So when you plug in 1 by 2, what is cos pi by 2? It is 0. And what is cos 0? It's 1. So what will you be left with? This to completely will be 0 only, na? When you plug in t as 1 by 2, cos pi by 2 will become 0. So 0 into anything is 0. When you plug in t as 0, this will become 0. 0 into anything is 0. So this completely is actually 0. You are left with minus 2 and then integration of cos. So upon pi comes outside. This is sine pi t 0 to 1 by 2. So minus 2 by pi. What is sine pi by 2? It's 1 minus 0. So you are getting minus 2 by pi. Oh, there's another pi. Sine pi t upon pi. Okay. So pi square and pi square. My bad. Right? This pi to chalo is there, but when you integrate cos pi t, again you will get sine pi t upon pi. So another pi comes into action and you get pi square, minus 2 pi square. What is this? The value of I. And what do you want? You want GIF of I into pi square. That means GIF of minus 2 by pi square into pi square. This gives you minus 2 whose GIF is nothing but minus 2. Is this making sense, everybody? Is this making sense? People quickly tell me this is a very, 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 very important question. Very, very important question. Guys, if it is not clear, stop me right now, interrupt me right now. If there's any doubt in any step, please, please bug me right now. Yes or no? Please tell me. Is it clear? Everybody in the chat. Do not ever open the brackets up and segregate the integration and perform the actual conventional traditional integration. No, 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 no. A big no. A very, very big no. Is it clear? Everybody stop me, tell me, is it absolutely crystal clear? Yes? Yes, if this is GIF, the answer is minus 2. If this is mod, answer is 2. So maybe there is some printing error because it's minus 2 is not there in the options. But I hope you understood. If it's GIF, the answer is minus 2. If it's mod, answer is 2. So maybe it's mod. But there is, there's an alternate approach to this. Very interesting alternate approach. I'll share that also with you because I'm sure you will like it. In any question like this is a more of a trick or a shortcut, I would say. See, the limits are 2 to 3. The midpoint of 2 and 3 is what? 5 by 2. 2 plus 3 upon 2, it's 5 by 2. So, take x minus 5 by 2 as t. This can be done directly. This is the catch. You can directly come to this step. Remember this step we had? We had definitely performed this step. Where is it? Where is it? Where is it? Yes, see, here. But you can directly come to this step just by realizing that 5 by 2 is actually the midpoint of the lower and the upper limit. The distance between lower and upper limit. The line connecting lower limit and upper limit, its midpoint is actually 5 by 2. So x minus 5 by 2 if you take as t, what happens? X minus 5 by 2 you take as t, your x turns to t plus 5 by 2. So your integral becomes what? This is again minus 1 by 2 to 1 by 2. dx and dt are the same. And what do you get? X by 2, t plus 5 by 2 minus 1 whole cube. So this gives you what? 5 minus 2, 3 by 2. So t plus 3 by 2 whole cube plus 4 minus what is x? T plus 5 by 2. See, 4 minus 5 by 2, 8 minus 5 is 3. 3 by 2 minus t. Yes, plus t plus 5 by 2. All of this into cos pi x. What is x? T plus 5 by 2. And then dt. This is minus sine pi t. I just told you. Just a while ago I told you how is this? Minus sine pi t. Yes? Yes or no? Now you will realize when you distribute the integral, what do you get? See, please understand, t plus 5 by 2, let me put it out of the bracket. 5 by 2 into minus sine pi t. Integral is minus half to half. 5 by 2 is a constant, but sine is an odd function. Integral will be 0 corresponding to this. When you multiply this with minus sine t, again when you open up the bracket, you will realize it is actually nothing but an odd function. In fact, what can you do is, you can club these two and then open up and get the final expression. And each of those parts of the expression, when you will multiply with minus sine pi t, each one of them will represent integral from minus half to half of an odd function. And that will keep on continuing to come out to be 0. All you will be left with is minus half to half t into minus sine pi t, which is the exact same step that we reached to right at the end, which is this. And then the product of this is even. Product of this is even, so it turns down to twice of 0 to half. And then apply the bypaths, apply the limit and get the answer. So this is an alternate approach, a tricky approach. If you remember this, great. If not, then obviously the conventional approach which I shared with you, which involves King's rule, is something that must strike you guys when you see a question like this. Because King's rule make it very, very easy. It makes it super easy, a very smooth glide. It makes it the journey of this question. It's a very smooth glide slide, isn't it? So do not ever open up the bracket and then integrate. Remember, King's rule comes to the rescue in such questions. And how are we manipulating our expression, which was a master stroke, which actually converted our integral into minus a to a, and then the even odd property came into action and actually killed the question. And of course, there is an alternate approach as well, which involves midpoint of the lower and the upper limit. Is it cool? Yes, ma'am, no, ma'am? Cool? All right. Tell me the answer of this question. dy by dx plus 10y equal to f of x when x is positive, where f is a continuous function such that limit of f is 1. What is the value of the limit of y of x as x tends to infinity? That means somehow the question is demanding to solve this differential equation. This is obviously a differential equation, no doubts about it. In fact, it's a linear differential equation, pretty straightforward, we can identify. F is a continuous function. Limit of f as x tends to infinity is 1, very important. What is the value of limit of y of x? So basically you have to find out the solution of this differential equation. Yes or no? Yes or no? Somehow dy by dx plus py equal to q has y as the solution. No, you want limit of y. So you need y. Y is nothing but y of x in my differential equation. This is what I need to find. Until unless I have my y, I can't compute limit of y as x tends to infinity. So I have to solve my differential equation. Let's start. Dy by dx plus 10y equal to f of x. Linear differential equation. Integrating factor is e to the power integration of 10 dx, which is e to the power 10x. E to the power 10x basically is your integrating factor. Now what you will do is something very interesting, very important, something you've never done before. Please listen to me carefully. This is something which is very new, very unique, out of the box. If you don't focus right now, such a question will be out of your league. It is off the table for you to get right. So you get y into integrating factor is equal to integration of q into integrating factor dx plus c. In questions like these, which is not a very common question, in questions like these which seem very easy, this question might look very easy to you. Oh my god, such a beautiful easy peasy differential equation is given to me. It's so easy, so simple. It's not. It's a trap. Why is it a trap? Because here I don't want c in picture. If I don't want a constant in picture, if I don't want a plus c constant of integration in picture, what do? I convert my integral into definite integral. Remember the journey from indefinite to definite. What is the best part about it? In indefinite, there is always a plus c. But the moment I apply the lower and the upper limit, the moment I attach a lower bound and the upper bound to the integral, my plus c gets vanished and I have no unnecessary plus c in my integral. So if I don't want a plus c, I want to put limits in my integration because my x is positive. It's greater than 0. Something like this. Here is 0, here is x. It's positive on the right of 0. My limits will be from 0 to x. This is the tricky part. Did you understand? Not a very regular category, I told you. When you immediately look at the question, it strikes to be very easy. Because there is a very straightforward linear differential equation sitting right in the beginning as the first statement. But it's deceiving. It's pretty deceiving, guys. Understand, I don't want a plus c. Why? In such a situation where I'm not aware of what my f is, I am not interested in a plus c. So what will I do? I will instead plug in the limits as 0 to x, keeping in mind that x was given to be positive. So this is how the relationship is, and hence from 0 to x. Okay, so y into e to the power 10x, and then you have equal to 0 to x f of x into e to the power 10x dx. Anybody, any doubt till here? Anybody, any doubt till here? Now, what do you want? You want y of x. You are interested in y of x. You are getting integral 0 to x f of x into e to the power 10x dx, and this is e to the power 10x. Basically, this e to the power 10x I have brought in the denominator here. Correct? Now, I want limit x tends to infinity. Here also limit x tends to infinity. How will this operate? Tell me. How will this operate? See, as x approaches infinity, f of x approaches 1. And as x approaches infinity, this approaches infinity. As x approaches infinity, this approaches infinity. So basically this is 0, or rather infinity by infinity form. If this is infinity by infinity form, this calls definitely for LH rule. Yes, differentiate the numerator and I am going to apply my Leibniz rule, Newton-Leibniz rule. There is only one variable involved, which is x. So you get f of x e to the power 10x. That's it. Whole upon 10 times e to the power 10x. And there is a limit x tends to infinity. So e to the power 10x, e to the power 10x cancels out. What are you left with? You're just left with limit x tends to infinity f of x upon 10. And as x tends to infinity, f tends to 1. So your answer is 1 upon 10, which is actually 0.1. So your limit x tends to infinity of y of x is coming out to be 0.1. Or 1 by 10, depending upon whatever the options are. It's allowed to give answer up to 2 decimal places, 1 decimal place, whatever. Is this making sense? Did you understand this question? Not a difficult question at all. I don't believe it's a difficult question, but it's a very new type of a question. When you look at the question statement, it appears to be very simple. I understand and I totally agree. You being a bit misleaded when you are solving the question, I can see you are a little misleaded, but you have to understand how to again bring yourself on track. Don't get derailed. Be on track. And what is the on track approach? I am not interested in a plus C because I don't know what my F is. How will I be able to proceed further? I don't have initial value condition also. How will I be able to do anything if I use my conventional approach of integrating my right hand side? I can't do anything. Now I'm stuck at this stage. So might as well, because I'm stuck, but the question is giving me a linear differential equation which kind of is not solvable only. So I'm going to get rid of C, and at the cost of that, how to get rid of C? The cost you have to pay is plug in the limits. Plug in the limits. When you plug in the limits, that's when the journey becomes very simple. You are then computing the limit which calls for LH rule and hence calls for the Newton-Leibniz rule, and then it's a very smooth sail to get the answer. But this question, guys, is a very new type of a question, very unique type of a question. So please make a star around it and don't forget to revise it before your actual D-Day. I might come up with more questions of this type in future when we are doing paper predictor sessions or actual mock tests when we are conducting. But this question specifically, I want you to make a star around it. Is this clear? I hope this is hashtag HDCC, everyone. Yes? Cool. Thumbs up in the chat. Hashtag HDCC in the chat. Smileys in the chat, everyone. Flood the chat with smileys. I hope these questions are giving you a feel-good factor and increasing your confidence question by question. Come to this one. Area bounded by the curve 4y square is x square times 4 minus x into x minus 2. What is this? Very distinctive type of area under curve. Very new, very distinctive, and something which was there in 2022 and students struggled a lot. This involves the loop. This involves the area bounded by the loop or area within the loop. The loop questions actually gave hard time to tons of students who sat in that year to give the JEE Main exam, and that's the point where all of us realize that JEE Main can give us surprises. Area between parabola and a line, ellipse and a line, whatever is the standard questions which you get, that though is important. But out of the box questions like these, where it's not very much directly possible to draw the curve, these are not some familiar functions, no, this is not the equation of some standard function. I can't identify as to immediately looking at the equation that, okay, this is what it represents. No, that's not in our data set of memory. No. Not at all. Not at all. And that's when JEE Main plays bouncer balls. And that's when Bhoomika Ma'am comes to the rescue. So, to hit a 6 even on the bouncer ball. Let's get started, guys. Let's start with observations. As I said, I'm always interested in dissecting the question because after that it becomes extremely easy, like a cakewalk. Very easy. So that's what we're going to do. First of all, you have 4y square equal to x square times 4 minus x into x minus 2. Guys, first things first. When you replace y with minus y, the curve is the same. Yes or no? But when you replace x with minus x, is the curve same? Try. When you replace x with minus x, right hand side becomes this becomes 4 plus x, this becomes minus x minus 2. So this becomes x plus 2 with a minus sign. No, it's not the same. X with minus x, not same. What does this mean? Y with minus y, it's the same. What does this mean? Your curve is symmetric with respect to x-axis. Yes or no? Yes or no, it's symmetric with respect to x-axis. First observation. Second observation, for what values of x? For what values of x is y 0? Please understand. I am going to rewrite the definition of this. I have 4y square equal to this. That means y square is equals to 1 by 4 times x square into 4 minus x into x minus 2. So y comes out to be plus minus 1 by 2 times, this is x, or rather x by 2 times root over 4 minus x into x minus 2. Is this agreed? This itself is a hint. When you say y equal to plus minus, that means there is a curve above x-axis with the plus sign and a symmetric curve below x-axis with the minus sign. The plus curve is above x-axis and its symmetric mirror image is the minus curve below x-axis. And both these, as I said, are symmetric. So if you have to draw the figure of y equal to this, only draw above x-axis and its mirror image falls below the x-axis. That's when you will get the entire curve. Okay? One more observation, guys. One more observation. See, when you plug in x as 4 and 2, please understand, or before that, let me talk about the domain. Okay, let me prioritize computing the domain. To compute the domain, I want y to be real. Y is what? My f of x, na? I want my f to be real. For my f to be real, my quantity sitting inside the square root has to be non-negative. Under root of only non-negative is real, na? So I should have what? 4 minus x into x minus 2 to be non-negative. Or I can say x minus 4 less than equal to 0. So you are going to get 2, 4 plus minus plus. So this implies x belongs to closed 2, 4. This is the domain, guys. Only this interval is the domain. Can you see this? Only this interval is the domain. The entire graph will be drawn only corresponding to the interval 2 to 4. Moreover, another observation, y of 2 is 0 and y of 4 is 0. At no other point is y 0. Because you can say at x equal to 0, y is 0, but 0 is not in the domain, na? So I can't take 0. Within the domain, in the closed interval 2 to 4, at what values of x is my y 0? Y is only 0 at the extreme points 2 and 4. Otherwise, it's nowhere 0 within my domain. Only at 2 and only at 4 it's 0. Now you know what you need to do. Now you know, guys. Now you know. Now I think the picture is absolutely clear. This is your 2. Let's say this is your 4. Now at 2 your graph is, at 2 your function is attaining value 0. Then it's coming back and again at 4 it's attaining the value 0. If at 2 it's 0, again at 4 it's 0, that means it has to come back, obviously. It has to come back and it is a continuous function, 100%. So I don't know, it might start like this, increase, decrease, whatever, but it will come back to 0. It can go into any ways and it will come back to 0. I am not interested in the actual trace of the curve. It might be like this, or it might just be like this. Also, I don't care. Or it might be like this, I don't care. But whatever is the shape, its symmetric shape will be below the x-axis. That is the only catch. Whatever is the shape above the x-axis, its mirror image will be the shape below the x-axis. So what am I going to do is, if I want the area of this complete region, what will I do? I will do 2 times 2 to 4, just the area of region above x-axis. I will perform 2 times area of the region above x-axis. This will give me my answer. So what is this? 2 times integral 2 to 4. The curve above the x-axis is corresponding to the plus sign, remember? Remember, x by 2 plus x by 2 root over 4 minus x into x by 2 plus x by 2 root over 4 minus x into x minus 2 dx. This 2 cancels out. Oh, not this 2, sorry, this 2. Okay, so you are getting integral 2 to 4 x into root over 4 minus x into x minus 2 dx. Now you have to tell me how will you solve. Now you have to tell me how will you solve. Tell me. This is your eye, right? Why do I have a smile on my face? Because again, the same, I would say, trick will come into action, and the trick is corresponding to the King's rule. What is the King's rule? I goes to what? Again, 2 to 4, 6 minus x. This will give you 6 minus x. Root over, this will give you 4 minus 6 minus x, which gives you 4 minus 6 plus x, which is x minus 2. And x minus 2 becomes what? 6 minus x minus 2. This gives you 4 minus x. Oh, it's the same. It's the same. So when you add, you get 2I equal to integral 2 to 4. This much part is the same. X minus 2 into 4 minus x. This much part is the same. Rest you will have 6 minus x plus x, which gives you just 6. Right? So 2 1s are 2, 2 3s are 6. I is simply coming out to be 2 to 4, 3 times just your square root. What is it? Under root of x minus 2 into 4 minus x dx. Can you see how beautifully we have gotten rid of this x? We got rid of this x using the King's rule. How beautifully. Yes or no? Tell me guys, yes or no. Is this understood? Is this understood? Because now things are very simple. This is 2 to 4 root over. This is what? 4x minus x square minus 2x. Okay. Wait a second. This is 4x minus x square minus 8 plus 2x. So actually this is giving you minus x square plus 6x minus 8. Yes or no? Yes or no? How can I complete the square? Minus common, x square minus 6x plus 8. Tell me, no? Is this cool? How can I complete the square now? If I just had, imagine, not a plus 8 but a plus 9, this would have straight away converted to x minus 3 whole square. Right? So instead, right now what I have in place of 9 is an 8. So what am I going to do? I know the manipulation, plus 1 minus 1. So you will get what? Minus of x square minus 6x plus 9 and then minus minus plus 1. Tell me if this is clear. Entire journey, is this clear? Yes, all of this is inside the square root only. I am not saying it's outside the square root. All of this is inside the square root. From here to here, here to here, here to here. Yes, so you get 3 times 2 to 4 And then you have what? 1 minus x square minus 6x plus 9 inside the square root dx. And as I told you, this is 3 times integral 2 to 4 root over 1 minus x minus 3 whole square dx. Can you see how beautifully things are automatically getting simplified? Can you see this? So I had x irritating me, King's rule got me rid of x. After that I had under root of a quadratic. I completed the square and I've reached here. Now obviously you know the next step. Take x minus 3 as t, dx comes out to be dt. If x is 2, t is minus 1. If x is 4, t is 1. So minus 1 to 1. This gives you minus 1 to 1. Very nice. Very, very nice. Minus 1 to 1. And what do you have? 1 minus t square. Root over 1 minus t square dt. This is like root over a square minus x square. Huh? But this is an even function. Yes, you are right. So this will be twice of 0 to 1. 2 into 3 will give you 6. 0 to 1 root over 1 minus t square dt. What is this? Huh? What is this? Quick, quick, quick. Tell me no. What is root over 1 minus t square? It is t upon 2 root over 1 minus t square integral from 0 to 1 plus 1 upon 2 sine inverse t from 0 to 1. 6 is sitting outside. So a's value is 1. So wherever in the formula we have t upon a or a upon 2, it's 1 upon 2 and t upon 1. Yes or no? Everybody, any confusion? Stop me right now. When you plug in t as 1, you get a 0. When you plug in t as 0, you get a 0. So this to completely vanishes. This is 0. You have what? 6 upon 2 sine inverse 1 minus sine inverse 0. Sine inverse 1 is pi by 2 and here you get 6 upon 2 which is 3. 3 pi by 2 is the answer. Please check this. Pi by 2 into 6 upon 2. 6 upon 2 is 3. So 3 pi by 2 is the final answer. Is this absolutely clear? Is this absolutely clear, guys? Not a very easy question, but I would say once we have dissected it completely from start to finish, you should not feel it's a very difficult question either. I told you it's a loop, not a very neat. It can be a neat loop as well. Neat loop means like this, right? It's a completely bounded figure. It can be neat also. It can be like this also. So questions like these are asked a lot. All you need to do is just get one part right. And in order to get just one part right, multiplied by 2, multiplied by 4, depends upon the question. But to get one part right, you don't need to get the actual figure. I have not differentiated or computed the critical points or found out the point of max, point of min. No. All I have done is at 2 my graph is 0, at 4 my graph is 0, at nowhere in between it is 0. And it is symmetric about the x-axis. Whatever is the graph above, its mirror image is below. That means between 2 and 4, it's certainly positive only. It is turning many times, I don't care, but it is certainly positive. So its shape can be anything, but its mirror image will be down. So all I need to do is just integrate from 2 to 4 the upper curve and multiply it by 2. And that's what I've done. The only problem was in integrating, I was facing trouble. So to simplify my integral, I have used my King's rule, after which I have used the completing the square method, after which I've used here substitution, and then I've used this formula in the end, which is under root a square minus x square. Yup. Please take some time to digest what I've done here. If there is any doubt, leave it in the comments right now. But don't go with half-baked knowledge. Don't say, yes ma'am, I've understood, even when how much you understood is half-baked. Full-baked. Perfect. Perfect it should be. Yes? Yes? Let's attack this question. Very nice, very simple. Very, very easy, guys. Very easy. Consider the function f and g, both defined from R to R, defined as f of x is 2x minus x square, g of x is x to the power n, where n is a natural number. Okay, if the area between f and g is half, what is n a divisor of? Very easy. Why? Because f of x is something which is 2x minus x square. So this is like x common 2 minus x. When you equate with 0, you get x as 0 and 2. And this is what? This is a downward opening parabola or upward opening parabola? It's clearly a downward opening parabola. So what does it look like? It's intersecting at 0 and 2 and it's downward opening. Somewhat like this. Please check, please check, please check. Is it downward opening? Guys, look at the figure very carefully and tell me if there is any problem. It's downward opening, minus x square plus 2x. Correct? Intersecting at 0, intersecting at 2. Perfect. Absolutely perfect. What next? Next, I want to plot g of x, which is x to the power n, where n is a natural number. Here, I want you to please notice, when you compute x square, when you plot the graph of x square, it is what? Drawn like this. This is x to the power 2. When you plot the graph of x cube, it is drawn like this. When you plot the graph of x to the power 4, again it's somewhat drawn like this. When you plot the graph of x to the power 5, again it's somewhat drawn like this. So no matter you have x square or x cube or x to the power 4 or 5 or 6 or 7 or 8 or 9, in the first quadrant, everything looks kind of the same. Can you see this? In the first quadrant, everything looks kind of the same. Yes or no? So it will go like this. Let me draw it with a different color. If the power is even, it's actually completing a parabola. If the power is odd, it's going like an odd function. So the blue can go above, the blue can go below, but this blue part is not actually going to impact my area because my area is coming out to be just this much. And that is why n is odd or even doesn't impact this graph or this region which I'm getting for the area. Because in the first quadrant, more or less every curve is looking the same for x to the power n. The problem is if n is even, it's a parabola, so other branch is going in the second quadrant. If n is odd, the graph is like a cube function, so the other branch is going in the third quadrant. But this blue branch, which is going either in the second or the third quadrant, is not impacting my area. So I don't care whether this n is even or not. Because the only part impacting my area is the curve in the first quadrant, which is more or less the same, corresponding to n being positive, n being negative, even or odd. Whether n is even or not, you can see in all these cases, in the first quadrant, the graph looks kind of the same. Okay, so this question was tricky in that sense. It could have been confusing if you were not able to understand that, okay, n being even or odd will actually not impact my shaded region. If you were trapped in that loophole, that okay, n is even, then this is the graph, n is odd, then this is the graph. In both cases, area will come out to be different. No, it won't. It won't, and that is why this is such a good question. It's such a good question. What is their point of intersection, everyone? Can you tell me? Pick up any n. Pick up any n and compute the point of intersection. See, for example, I have 2x minus x square. I equate with, let's say, x square. I take n equal to 2. So you have 2x equal to 2x square. You get x square equal to x. X into x minus 1 is 0. So x is 0 and 1. So one point of intersection is 0. Other point of intersection is 1. Even if you would have taken not x square but x cube, point of intersection would have come out to be 0 and 1. For x to the power 4, again 0 and 1. X to the power 5, again 0 and 1. So the points of intersection for both these curves are nothing but 0 and 1. And this area is actually given to you as what? Half. So you are getting integral from 0 to 1, upper minus lower. Can you see this? Upper is what? 2x minus x square. Minus lower is what? X to the power n. Yes, this is given to you to be half. So you have to write x square by 2 minus x cube by 3 minus x to the power n plus 1 upon n plus 1. From 0 to 1, this is, guys, half. So you will get 1 minus 1 by 3 minus 1 by n plus 1 is actually 1 by 2. So this is 2 by 3 minus 1 upon n plus 1 is actually 1 by 2. So what are you getting? Tell me. 3 times n plus 1 Okay, 2 times n plus 1 minus 3, this is 1 by 2. So 3 times n plus 1 equal to 4 times n plus 1 minus 6. So 6 is equal to n plus 1, n is equal to 5. Of course, there is a shorter way to do so as well. So I'm sure you would have reached the answer 5 in a shorter way. N is 5. If n is 5, very simple. I've just integrated, computed with half, equated with half. N is 5. N is 5. What is n the divisor of? N is a divisor of 15, of 20, of 30. It's not a divisor of 12. This is a multi-correct question. And just see how easy peasy lemon squeezy question. Yes or no? Guys, quickly tell me, wasn't this an easy peasy lemon squeezy question? Yes, supremely easy, isn't it? Isn't it? But the only thing to decode was the graph and the interaction of the graph to get the region. If you get the region right, great. If you don't get the region right, you get confused as to how will x to the power even interact with my downward opening parabola and how will x to the power odd interact with my downward opening parabola. If you get confused in their interaction, this question becomes tough for you. Otherwise, it's a very easy question. You can make it tough by yourself, for yourself. Individually, if I have to judge it, it's an easy question. Okay? Sometimes we create difficulties by ourselves, for ourselves, and that is where nobody can help us. That is where nobody can help us. B, C, D, absolutely correct. All right. Come here, everybody. F from R to R, continuous function, satisfying this. Then many options are given here. Limit of f is 2 or minus 2 as x tends to infinity and minus infinity. Okay. F has more than one point in common with x-axis and f is an odd function. Tell me, not a very difficult question again. Not a very difficult question again, because here again, because I want to talk about the limit of f, now that you've solved so many questions, I think it's easy for you to decode the technique to crack a question. Now at least, after we've solved questions for so long, that to such brainstorming, such new, such deep variety of questions, now I feel it's easy for you to decode what should be done. At least the starting approach should be something which should strike you. Here, I want to compute limit of f. Then I want to talk about f has more than one point common with x-axis. Then I want to talk about f being an odd or even function. If I want to talk about the features of f, the behavior of f, I might as well should have f in the first place. So to get my f, again the same approach, guys. This is kind of, I would say, a repeated question. In my judgment, it's not a repeated question, but the approach is repeated. Why? Because f is trapped here. One f is outside, but one f is trapped. No, so in order to release that f, until and unless I release it, I can't get individual explicit definition of f. No. So to release this f, make it free from integral, I will have to use the tool of differentiation. Because only differentiation can cancel my integration and hence my f can be released. That is why I will be differentiating. Differentiate both sides. Okay? What will you get? F dash x plus, again, Leibniz rule, everybody. This is involving a single variable, so I can apply. X into f of x, differentiation of x is 1 only, plus 2x equal to 0. Check this. Now, f of x, if you treat as y, this is nothing but dy by dx equal to minus xy minus 2x. So this is like x common or minus x common y plus 2. So it's more like a variable separable. Dy upon y plus 2 is equals to minus x dx. Can you see this? Can you see this? Very simple variable separable. So right in the beginning, if you look at the question, it was not looking like a differential equation question, but we understood the intention. We browsed the options. We browsed through the options. We realized I would need my individual definition of f in the first place. For that, I would have to release f from within the integral, for which I will have to differentiate. Once I differentiated, obviously after simplifying, I got a differential equation, which on further simplifying converted to variable separable. Now what? This is what? Log of y by 2. Log of y plus 2. Sorry, log of y plus 2 minus x square by 2 plus c. Anybody, any doubt? Again, why am I saying the question is repeated? The question is not literally repeated, but what I'm about to speak is something I've just spoken a while ago. I just spoke that a while ago, that in such questions, you never directly get an initial value condition, but it's hidden there. How is it hidden? You have to treat x to be 0 so that your integral becomes 0 to 0 and the value of this entire integral becomes 0. So whatever your lower limit is, take x to be that so that the upper and the lower limit match and your integral vanishes. Right now your lower limit is 0, so you will consider x as 0. So this will get plus 0 is 0. So basically f of 0 is 0. This is an initial value condition which you have yourself extracted. You've dug deep and you've extracted. It was not given in the first place. You have extracted. Okay, f of 0 is 0. F of 0 is 0, so you get log 2 equal to 0 plus c. So this is your c. You get log of f of x plus 2 is equal to minus x square by 2 plus log 2. Now minus x square by 2 again convert into log. No, you will get log of e to the power minus x square by 2. Log m plus log n gives you log of m into n, 2 times e to the power minus x square by 2, and this is log of f of x plus 2. Please check this quickly. If there is any doubt, tell me right now. Log cancels out. Your f of x has come out to be 2 times e to the power minus x square by 2 minus 2. Tell me. Quick, come on. Is this making sense? Is this making sense? You have your f in picture. Now the question can ask anything. It can shoot question from any direction on f and you will be able to answer within no time. Is this cool? Now let's start. What did the question say? Limit x tends to infinity of f and limit x tends to minus infinity of f. Let's check. Limit x tends to infinity of f means 2 common e to the power minus x square by 2 minus 1. See, as x approaches infinity, x square approaches infinity, x square by 2 approaches infinity. Minus x square by 2 approaches minus infinity. So e to the power minus infinity, you remember this, right? The graph of e to the power x. As you approach to minus infinity, exponential approaches to 0. 0 minus 1 will give you minus 1. So this part is approaching to minus 1. What about limit x tends to minus infinity? Limit x tends to minus infinity. This is 2 to the power minus x square by 2 minus 1. If this part is approaching to minus 1 means finally it's approaching to minus 2, na? Did you understand? Because 2 into minus 1 gives you minus 2. Come down now. Here, if x approaches minus infinity, x square approaches infinity. Upon 2 approaches infinity. Minus of this approaches minus infinity. Again, this approaches minus infinity. So again, this part approaches 0. 0 minus 1 is minus 1. That means this part approaches minus 1. 2 into minus 1 gives you minus 2. So, what is coming out to be the right answer out of A and B? This is not right. This is right. F has more than one point in common with the x-axis. That means what? When you say the graph of f cuts the x-axis more than once, when you say f has more than one point common with the x-axis, means the graph of f is cutting the x-axis more than once. What is the equation of x-axis? It is y equal to 0. That means the point of intersection between f and y equal to 0 are more than 1. Are more than 1. So let's see what is my f. Basically, f of x equals 0 is what I am interested in solving. 2 times e to the power minus x square by 2 minus 1 is 0. This will give you e to the power minus x square by 2 equal to 1, which is what? E to the power 0. So minus x square by 2 is 0 when you solve, which gives you x is 0. So my graph of f is cutting the x-axis at exactly one point, which is corresponding to x equal to 0. It is not cutting the x-axis at more than one point. It's only cutting my x-axis at one point corresponding to x equal to 0. Okay? Okay, if you plug in x as 0, y will come out to be what? What is your f of x? This. Plug in x as 0, e to the power 0 is 1, 1 minus 1, 0, your y will also come out to be 0. So only at origin, my graph of f is cutting the x-axis. Only 0, 0 is the common point sitting on the x-axis and my function f. Otherwise, no other point is sitting in common. F is an odd function, is it? No. What is f? 2 times e to the power minus x square by 2 minus 1. Substitute x with minus x. Replace x with minus x, again you will get the same function. So because f of minus x is same as f of x, this implies f is even and not odd, baba. Only B is correct. Only B is correct. All right. Such a brilliant question. So the start of the question was not something that was new, I believe. The computing the initial value condition again was not something which was new, I believe. But once you have your f, then the analysis which this question asked us to do upon f, that is something new. That can change from question to question. The journey of computing f can somehow be the same, but once you have your f, after that what is the question demanding from you to comment upon f can be different from question to question. Is that okay? Is that okay? All right. Shall I move ahead? Are you tired? I want to move ahead. This is correct. All these are wrong. Now it's time for you to brainstorm upon a difficult question. This is not something which is very easy. I would straight away tell you this is not very easy. But guys, why I want you to solve this question is because it falls in a standard category. Questions like these fall in a standard category and you must know the process of solving them. There is no shortcut as such. I will try to tell you in between hacks when we solve the question, but you must know the approach to crack this question, the step-by-step procedure to think about solving the question and reaching the answer. And that is why this is one question I want to solve with you specifically, and I want all your attention, all your focus onto the screen with complete commitment and zero distraction. So I'll give you 1 minute to brainstorm upon this and then I'm getting started. All right, quickly brainstorm and tell me if you're coming up with some approach. So could you figure out? Tell me, what is the value of this integral? Now this, as I said, is a very standard type of an integral which has high probability to land in your paper in the upcoming JEE Main 2025. But the problem is, it's not a very easy question. I won't say that the technique to crack it will strike you immediately. So this happens to be representative of a certain variety. So let's understand how to crack any question which falls into this category. Okay, understand. Here, I want you to very closely observe the numerator and the denominator of the integrand, all right? And particularly, please consider that your denominator is representing, let's say, I2 and numerator is, let's say, representing I1. 220 in the numerator and integral from 0 to 1 of whatever in the denominator. I want you to understand that I2 needs to be worked upon. I2 needs to be worked upon to somehow get converted in terms of I1. That is the approach. I2 needs to be worked upon to somehow get converted in terms of I1. We have to work upon I2, somehow manipulate it, somehow work upon it, somehow use whatever knowledge we have and convert it, reduce it in terms of I1. Let's see how to do that and why exactly am I able to do that also. So once we're done with this question, then you will understand why this happened, why we did that, and why this was the perfect approach to attack it. So I2 I am treating as my denominator. This is integral 0 to 1. T to the power 1004, inside you have 1 minus t to the power 2010 and whole to the power 1004 dt. Now guys, listen to me very carefully. Look at the numerator for once. Look at the numerator for once and just see the variation of the denominator from the numerator. When you observe this for a while, you will realize that the catch is, take t to the power 2005 as, let's say, u. This has to be the perfect substitution in my scenario. Why? Because when I differentiate further, I get 2005 t to the power 2004 dt is equal to du. Okay, fine. So t to the power 1004 is written here and dt is written here. So what should I do? Baba, I have t to the power 1004, not 2004. So rather, what is the correction? Yes, this should be 1005. Here it should be 1005 and here it should be 1004. So that t to the power 1004 dt completely gets compressed to what? Du upon 1005. So second step, 1 upon 1005, and what do you have? 1 minus whatever du. Whatever means t to the power 2010. T to the power 2010 बच्चे is t to the power 1005 whole square only na, which is u square. So 1 minus u square. Yes or no? Yes or no? And when t is 0, u is 0. When t is 1, 1 to the power 1005, again 1. So u is again varying from 0 to 1 only. That means my I2 is now looking like what? My I2 now is looking like what? 1 upon 1005 integral from 0 to 1, 1 minus u square whole to the power 1004 du. Correct? 1 minus u square whole to the power 1004 du. This is my U2 as of now currently. And my target, do not forget, is to convert it in terms of the numerator. Numerator looks like t into 1 minus t raised to the power 1004. T into 1 minus t. What is that? Striking. Is something striking? What is that reminding us of? T into 1 minus t. Some signaling? Some hint? Can you catch the hint? See, numerator is t into 1 minus t whole to the power 1004, and right now I have 1 minus u square. Obviously, I am interested in what? Look at the limits. 0 to 1. A plus b minus x, 1 minus t, or 1 minus x. X and t are dummy variables. I don't care. Clearly, my agenda to convert I2 to I1 right now at this stage is reminding me of, very true guys, King's rule. The King's rule. Apply it, apply it, apply it. 1 upon 1005 integral from 0 to 1, and how will you replace u? You will replace u with 1 minus u. So 1 minus u square whole to the power 1004, and this is du. Please simplify this. Simplify this, you will get 1 minus 1 plus u square minus 2u, and this is whole to the power 1004, which gives you 1 minus u square plus 2u. So this gets cancelled out, and all of this to the power 1004, which means what? U comes out common, minus u plus 2, or 2 minus u you can say. All of this to the power 1004. That means in the next step I can very confidently write a simplified version of this, which is what? 0 to 1, u to the power 1002 minus u to the power 1004 du. Now I am pretty near to I1. Can you see that? I am pretty near to I1. I1 is t to the power 1004 into 1 minus t to the power 1004. Right now I have u to the power 1004 into 2 minus u to the power 1004. I don't want 2 minus u. I want somehow like u minus 1 or 1 minus u. I want actually 1 minus u, not 2 minus u. So what should I do? See, I'm making you realize how I'm manipulating and why this manipulation is actually working in my favor. Can you see this? Is everything visible clearly? Can you see this, guys? Now you know I'm very close to I1 but not exactly able to attain kind of I1. Or my expression is not in terms of I1. What will I do? What do I want? I have 2 minus u, I want 1 minus u. See, I have 2 minus u, I want 1 minus u. So I have 2 minus u, I want 1 minus u. If I just replace u with 2u, 2 comes out common, I get 1 minus u. Is this making sense? Now, I can't replace u with 2u, right? So in other words, what I actually mean is, you understood the drill, replace u with 2v. I'm just going to convert everything in terms of v. U, v, whatever, x, t are all dummy variables. But you understood my approach, why I'm doing this, because 2 will come out common, leaving me with 1 minus u, which is going to match my numerator integral, which is I1. Correct? So this will give you du is equal to 2 times dv. So what will you do? You will replace u here and you will replace u here with 2v. So you will get, what will you get? Quickly, 1 upon 1005. Next step is integral. When u is 0, v is 0. When u is 1, v is 1 by 2. Correct? So this gives you 0 to 1 by 2. Next is u to the power 1004 means 2 to the power 1004 into v to the power 1004. Correct. Now 2 minus u gives you 2 minus 2v to the power 1004, which gives you 2 to the power 1004 into 1 minus v to the power 1004. So 2 to the power 1004 into 1 minus v to the power 1004. And du is nothing but 2 dv. du is nothing but 2, this is 2 here, and this is dv. Is this much making sense, everyone? Any doubt, any confusion till here? All of this is understood, and beyond that, all of this is also understood. So 2 to the power 1004 plus 2 to the power 1004 is 2 to the power 2008. It will come out. So 2 to the power 2008 into 2 upon 1005, you have 0 to half. V to the power 1004 into 1 minus v to the power 1004 dv. Now, this is a wonderful stage to be in. Why? Because my integrand, as you can see, is perfectly resembling the integrand of the numerator expression. But the problem is the limits. Problem, bachche, is limits. And this is where another very tricky and a very wonderful concept comes into picture, which I want all of you all to take a note of, make a dabba around this result, this formula, this idea, which should strike you in any situation like this. What is that? You remember integral 0 to 2a f of x dx is twice integral 0 to a f of x dx. But this happens if and only if f of 2a minus x is equal to f of x. How many of you all remember? How many of you all remember? How many of you all remember this? Huh? If I treat a as half, just listen to me. If I treat a as half, I will get twice of integral 0 to half f of x dx is equal to integral 0 to 1 f of x dx. Yes or no? Yes or no? But this can happen only when f of 1 minus x is equal to f of x. Is that true? Let's check in our actual scenario. This is my function over which I want to apply. This is my function over which I want to apply this result. So this function let me call as f of v. So what is my f of v? It is v into 1 minus v to the power 1004. What about f of 1 minus v? 1 minus 1 plus v. Again, this will be same. F of 1 minus v is the same. V into 1 minus v raised to the power 1004. They both are same. No, they are equal. They are equal. So what am I going to do is this complete part, bache, this complete part of 2 times 0 to half, this part. Can you see the orange bubble? 2 times 0 to half f of v dv is nothing but 0 to 1 f of v dv. And hence what you get in the next step is 2 to the power 2008 upon 1005, 0 to 1 v into 1 minus v to the power 1004 dv. This is your I2, and now your limits are no more 0 to half, they are actually 0 to 1, and this is I2, this much integral. What is this? Isn't this I1 upon 2 to the power 2010? Huh? Arey Baba, tell me, no? What is this integral 0 to 1 v to the power 1004 into 1 minus v to the power 1004? See, I want the value of this integral, isn't it? Please understand. Please understand, I want the value of this complete integral. So I will have 2 to the power 2010 into integral 0 to 1. Please understand, t into 1 minus t to the power 1004 dt. This is the numerator. And my denominator is turning out to be what? I2 is what? 2 to the power 2008 upon 1005. So upon 1005 goes actually here into again the same integral. V or t, they are dummy variables. So t into 1 minus t whole to the power 1004 dt. Yes or no? This and this completely cancels out. You're left with 1005 into 2 square, which is 1005 into 4. Can you see this? This is 4020. Such a nice question, yeah, such a brilliant level question, but I completely understand that immediately it cannot strike. The approach cannot strike. And that is why I want you to take a very special note of this question. In any question like this which challenges you on solving such an integral, please focus on the look of the denominator and the numerator expression. You can clearly see that somehow there is a resemblance, but some part of it is different. Much part of it is kind of resembling, but some part of it is different, and hence kind of conversion is possible from one to the other. Pick up the denominator. You saw how I manipulated. You very nicely saw how I manipulated, right? This was the trick step, the major trick step. Remember, I was doing a hit and trial in the beginning. I took t to the power 2005 as u, but that didn't work. Then t to the power 1005 as u, when I substituted, that worked, because t to the power 1004 into dt completely dissolved to becoming du. So that's how substitution worked, right? After which I applied King's rule, a very important step. After applying the King's rule, I realized that I don't want 2 minus u, I want 1 minus u, and I explained why I had to substitute u as 2v, because that only gave me 1 minus u in picture, because we know the target. We want to convert it in terms of the numerator. And after that, this result is a superstar result here. How have we incorporated this result? Just because we wanted to convert limits which were 0 to half into 0 to 1. So this result came into picture and helped us. Is that cool? Is that cool? Yes? And that's the answer. So everyone, is this question completely clear? Hashtag HDCC everybody. I want all of you all to comment in the chat right now. Is this question hashtag HDCC? Everybody right now in the chat very quickly. Yes? All understood? All crystal clear? Not even an iota of doubt? But I would say again, wait a second, I would say again that please mark this question for review, to come back to it again, because this is of a distinctive type and I don't want it to be erased from your memory. Alrighty? Now that we are through with this question, C is the right answer. Let's move to the next one. Without any further ado, another mind-blowing question waiting for your attention. F of alpha is given to you. Alpha is some positive quantity. And I am being asked, what is the value of this expression? Now, questions like these, first of all, are very common in your JEE Main exam. And I won't say they are difficult questions, because in a way the question itself is giving you a hint as to what to do. What is it saying? F of e cube plus f of e to the power minus 3. What is this? This is like f of e cube plus f of 1 upon e cube. And what you have as a given fact is f of alpha. So if, let's say, I take alpha as e cube, which is 100% positive, somehow f of alpha plus f of 1 by alpha, if I somehow figure out what is f of alpha plus f of 1 by alpha, on plugging alpha as e cube, I will get the value of my required expression. Did you understand? So I kind of examined the required expression and tried to convert it to a general setup. If I somehow get the value of f of alpha plus f of 1 by alpha, a solved value, something which is very resolved and simplified, then in place of alpha, I will just quickly substitute e cube and I will get my answer. So the hint is this only. This is what I need to find. Actually, this is what I need to find. After that, finding the required expression will be a cakewalk. Okay? So listen to me, how exactly do we proceed? Try it out as well by yourself. This is 1 to alpha log t to the base 10 upon 1 plus t, and this is dt. I want f of 1 by alpha. So f of 1 by alpha, if alpha is positive, 1 by alpha is also positive. So I will get 1 to 1 by alpha log t to the base 10 upon 1 plus t dt. Now the problem with f of alpha plus f of 1 by alpha is, when I want to perform their addition, I would want their limits to match. You can add two integrals only and only when their limits match. So what will you do? Tell me. What will you do? Right now the limits are not matching, no? Right now the limits are not matching. I want the limits to match so that I can add the two integrals. Right now the integrand is matching, but limits are not matching. Rather, I want the contrary. I want the limits to match. I don't care if the integrand doesn't match. At least I'll be allowed to add the integrals. Right now, I can't add the integrals and compress them into or dissolve them into one, combine them into one. I can't do that right now. So a substitution comes into picture over here. What is it? Replace t with, let's say, 1 by p. So dt is equals to minus 1 by p square dp. What about the limits? When t is 1, p is also 1. When t is 1 by alpha, p is alpha. You can clearly see lower limit, upper limit, lower limit, upper limit. It's matched. Let's see how the integrand is changing. So log t becomes log 1 by p to the base 10 upon 1 plus 1 by p, and this is minus 1 by p square dp. So 1 plus p by p. By p comes here. So this p cancels out, minus 1 by p dp. Okay, fine. Minus 1 by p dp. That too, this p comes over here, you get minus dp. Did you see how I have resolved? Huh? Did you see how I resolved? Another minus sign can come into picture because this is log 1 by p, which is p to the power minus 1. This minus sign will go ahead and will make this minus sign also vanish. They will become plus. Clear? You had log 1 by p. You wrote it as log p to the power minus 1. Minus 1 went ahead. Already there was a minus sign because of this, and hence minus minus became plus. Now there is absolutely no minus sign. Now what are you going to do? See, f of alpha is completely sorted. We are trying to sort f of 1 by alpha. What are you going to do? Look at this. The denominator is giving you a very shout out loud hint. P into 1 by p. Do you remember? 1 upon p into p plus 1. How do you break it up? You remember we have learnt in the sequence series chapter summation 1 upon n into n plus 1. How do you break it into how do you break the general term into the difference of two consecutive terms so that when you open the series up, consecutive terms get cancelled, which is your rain method or telescopic series. So it's a very, very common series expression or the general term of the series 1 upon n into n plus 1. How do you simplify it? How do you break it into the difference of two consecutive terms? Quickly tell me. Quickly. Isn't this 1 upon p minus 1 upon p plus 1? So p plus 1 minus p and p into p plus 1. This is cool. So I will write this as 1 upon p minus 1 upon p plus 1. Why am I writing this? This is equal to 1 to alpha, right? Right? What is this? So this is basically p minus, yeah. Okay. Now what do you get? Log p to the base 10 upon p minus, and this is dp, minus integral 1 to alpha log p to the base 10 upon p plus 1 dp. Is this cool? Please tell me if there is any doubt. Is this cool? I have divided this into two integrals and you won't believe. What is this integral? Log p upon p plus 1 integral from 1 to alpha. It's resembling log t upon t plus 1 integral from 1 to alpha, which is nothing but f of alpha. This is your f of alpha. Check this out. Quickly tally. F of alpha is already written on that corner and this is also resembling p and t are just dummy variables. So what do you get? You get f of 1 by alpha plus f of alpha is equal to what? So you started with f of 1 by alpha. It is coming out to be this integral minus f of alpha. So f of 1 by alpha plus f of alpha is equal to what? Integral 1 to alpha log 10. Here there is a p and there is a p here. and there is dp obviously. What do you think I should do? Huh? First of all, if you are thinking, ma'am, take log as t, ma'am, take log p as t, so 1 by p dp will give you dt. So 1 by p dp will get completely converted to dt. You cannot do that because the base is not e, bache, the base is 10. This is a very minute mistake which many students have committed, and students continue to commit this mistake. First of all, convert it to a natural log, or you can use the derivative with the base not equal to e. Let's say, let me make it easy for you. So when you have log p to the base 10, this is equal to log p to the base e upon log 10 to the base e. Now log 10 to the base e is a constant which is ln 10, correct? Here you are left with ln p upon p, this is from 1 to alpha dp. Now you can do that. Now you can 100% do that you treat ln p as t, so 1 by p dp is equal to dt. So what do you get? 1 by log 10. Okay, 1 by p dp is dt and this is t dt. When your p is 1, log 1 is 0. When this is alpha, this is log alpha. Please tell me, illusion. This is 1 upon log 10 and this is t square by 2. Let me pull out the 2 here. So this is t square and this is 0 to log alpha. Yes ma'am, no ma'am? Huh? Log alpha whole square and that's it. Yes or no? Yes or no? Anybody, any doubt, any confusion, any problem, please look at the complete solution. We have not yet reached the answer, but till here, is there any doubt, anybody? Huh? Log alpha whole square upon 2 log 10. Log alpha whole square upon 2 log 10 is this. Log alpha whole square upon 2 log 10. Now, if you plug in alpha as e cube, you will get f of e cube plus f of 1 by e cube is equal to log of e cube. Log of e cube, which gives you 3 into 1 whole square, which gives you 9. 9 upon 2 log 10, which is your answer. Isn't this a wonderful question? So all the questions that we are solving today are all very nice, very rich quality questions, guys. None of the questions are just randomly picked up and brought into practice. No, not at all. Every question has been cherry picked. A lot of brainstorming, a lot of thought has gone into selecting these questions, cherry picking these questions. A lot of intention and thought has gone into that. So I hope you're finding the session insightful. If you are, do not forget to hit the like button and also make sure that you are keeping on writing the concepts of the results or any catchy step, any trick step, any different approach which you've come across in the question in a dabba beside it, inside a box beside it, because that is what is the major takeaway from the question, and that is what you have to majorly revise in the end when the class is over or when you are revising all this content. Okay, is this cool? So here the question itself gave us a hint that you please compute f of alpha plus f of 1 by alpha, which we were very nicely, very diligently into computing. We had f of alpha, we tried computing f of 1 by alpha, very nicely we were manipulating the expression. We also used 1 upon p into p plus 1 to be replaced and rewritten as 1 upon p minus 1 upon p plus 1. Very important fact, very little fact, but must remember fact. Right? After that, we had the expression, we in the end plugged in alpha as e cube and bingo, we had the answer. I hope the flow is clear. I hope the concept is clear. I hope completely the question is in your head, internalized in your system. Alrighty then, let's go to the next question, which is on your screen now. Okay, so 9 upon 2 log 10 is the right answer, which is option D. And comes the next question. Brilliant question again. Now, this is kind of differential calculus, kind of integral calculus. So, let's see. At a point, everything gets mixed. There comes a point where everything gets mixed. So, let's start. Look at this question. F is given to you as a branch function or a piecewise defined function. B is real. Question says if f is continuous at 4, when you say continuous at 4, it means left hand limit at 4 is equal to right hand limit at 4 is equal to value of the function at 4. And 4 itself is the break point, you can see that. So at the break point or the connecting point, my function is 100% continuous. Which of the following statements is not true? Mind it guys, the question says it's not true. Okay, don't miss out on this very powerful statement. Which of the following is not true? Let's start. The question talks about f dash not being differentiable. F dash 3 plus f dash 5, f is increasing, f has local minima, local maxima. So everything about f dash is being discussed in the options. Let's first of all exploit the fact that f is continuous at 4. When you say f is continuous at 4, as I said, left hand limit at 4 equal to right hand limit at 4 equal to value of the function at 4. So what is the right hand limit at 4 or what is the left hand limit? Left hand limit is 4 square, which is 16 plus 4b. This is your left hand limit. Yes or no? Can you see this? From here I will get the left hand limit. Continuous limit of a continuous function 16 plus 4 into b. This is your left hand limit. This is also the value of the function at 4, right? What is the right hand limit? This is 0 to 4, 5 minus mod t minus 3 dt. The problem with this expression is because the integrand involves mod and I have my limits from 0 to 4, something needs to be fixed. I can't work like this. I have to understand that Baba mod t minus 3 is actually t minus 3 when t is greater than or equal to 3 and it is 3 minus t when t is less than 3. Okay, that means you will have to be. Please tell me if this is understood. And when your t is greater than 3, you are in this range 3 to 4, your mod of t minus 3 opens as t minus 3. So this is 8 minus t. Yes? Yes or no? What do you get? 2t plus t square by 2 from 0 to 3 plus 8t minus t square by 2 from 3 to 4. Can you calculate this quickly? This is 6 plus 9 by 2 plus 32 minus 16 by 2 minus 24 plus 9 by 2. So tell me 32 and 6 is 38. 38 minus 4 is 34. 34 minus 10, 24 minus 10, 14. Okay, so this is 14. And then I have what? 9 by 2 minus 16 by 2. This is minus 7 by 2. And minus 7 by 2 plus 9 by 2 is 2 by 2, which is plus 1. So this is coming out to be 15. Basically, you are getting the value of this as 15. So 16 plus 4b is coming out to be 15. 16 plus 4b is equal to 15. That means 4b is equal to minus 1. b is minus 1 by 4. Very nice. Very nice. Very nice. Is this cool? The moment you've got b as minus 1 by 4, now you can very explicitly write f without the involvement of any unknown. Because initially the case was this b was the unknown, right? Which was quite disturbing. So now we have the value of b, which is minus 1 by 4 plugged in, and bingo, I can proceed. I will get f of x equal to, what is this? Integral 0 to x, 5 minus mod of t minus 3, all of this dt for x greater than 4. And this is x square minus, what is b? b is minus 1 by 4. So minus 1 by 4 x here when x is less than or equal to 4. It's x square minus x by 4. Now that you have this, look at the options. Options talked about f being differentiable at 4, f dash being differentiable at 4. They are two very different stories. F being differentiable at 4 requires you to analyze f dash. F dash being differentiable at 4 requires you to analyze f double dash. So what is f dash? Let's first compute f dash. So here I will get my Newton-Leibniz rule. I will get 5 minus mod of x minus 3 when x is greater than 4, and this is 2x minus 1 by 4 when x is less than or equal to 4. The point is, because x is greater than 4, that means obviously x is greater than 3, my mod of x minus 3 will open like x minus 3. So this is simply x minus 3. So you get 5 minus x plus 3. This is 8 minus x. Please tell me. So you have f dash completely described, okay? Now you can very neatly write f dash. This is 8 minus x when x is greater than 4, and this is 2x minus 1 by 4 when x is less than equal to 4. So in order to find out whether f is differentiable at 4 or not, it is continuous at 4, that is given to us, but we still don't know whether it is differentiable at 4 or not. So I need to analyze f dash. So f dash of 4 from the negative is coming out to be 4, but f dash of 4 from the positive, from the positive it's coming out to be 4, from the negative let's find out. 2 into 4, 8, 8 minus 1 by 4, 32 minus 1, 31 by 4, 31 by 4. So left hand derivative and right hand derivative are not matching. That means f is not differentiable at 4. F dash doesn't exist at 4. F dash doesn't exist at 4. F is not differentiable at 4. But the question says something else. Question says, is f dash differentiable at 4 or not? F is not differentiable at 4. F is not differentiable at 4, which means f dash doesn't exist as a finite real quantity. Now for a second, treat f dash like an individual function. If f dash doesn't exist as a finite real quantity at 4, that means f dash 4 is not well defined. Until and unless the function's value at a point is not well defined, it's not real, it's not fixed and finite, we cannot talk about continuity of that function at that point. Because for a function to be continuous at a, it should be well defined at a, right? Because left hand limit equal to right hand limit equal to value of the function at a, correct? So if f dash is not defined at 4, that means I can't talk about f dash being continuous at 4. And if it's not continuous, can you say it's not differentiable? That's where you're stuck. See, f dash is not defined at 4, which means f dash is not continuous at 4. Agreed. But not continuous, does it imply not differentiable? Tell me. Differentiability implies continuity, not continuous implies not differentiable. So yes, if f dash is not continuous at 4, it will not be differentiable at 4 as well. So this is like a flow in which you can understand if your concepts are extremely clear. I'm not writing anything from a while, right? It's been a short while. I've just been thinking, analyzing and explaining you the conceptual flow. If f is not differentiable at 4, doesn't exist as a finite, fixed, well-defined real quantity. So if f dash 4 doesn't exist, that means I can't talk about f dash being continuous at 4. It can't even be talked about. So if it can't even be talked about, then obviously it is not continuous at 4 and hence it's not differentiable at 4, because not continuous implies not differentiable. Differentiability implies continuity, so its counter is also true. That means contrapositive is true. Not continuous implies not differentiable. So definitely it is not differentiable, but let me take this opportunity to actually teach you a conventional method. See, f dash is written over here. In order to check the differentiability of f dash at the break point, I will compute f double dash. I will compute f double dash. F double dash will come out to be what? 8 and 2. 8 over here and 2 over here. Check this out. X greater than 4 and x less than equal to 4. Can you see this, or is there any problem? Huh? Oh, this is minus 1, not 8. What am I writing? This is minus 1 and here this is 2. This is correct. This is correct. Now you can see f double dash of 4 from the negative, f double dash of 4 from the positive. From the positive it's minus 1, from here it's 2. They are unequal. That means f dash is not differentiable at 4. This is like a conventional method, just like we proved f is not differentiable at 4 by analyzing f dash's left hand and right hand limit at 4. Similarly, we have proved f dash is not differentiable at 4 by analyzing f double dash's left hand limit and right hand limit at 4. Is that making sense? Another way could have been through graph. So what is my f dash? Either you compute f double dash, or there is another approach. This is 8 minus x when x is greater than 4. And this is 2x minus 1 by 4 when x is less than or equal to 4. Is this correct? Please check. Cool. Now I want you to draw a graph. Please guys, invest some time and draw a graph. Greater than 4, let's say this is 4, let's say this is 8. Is greater than 4. Alrighty, alrighty. At 4 the value is what? 31 by 2. Yes or no? At 4 the value is what? 31 by 2, but corresponding to this line. Corresponding to this line, so this line is actually going like this. This point is 31 by 2. Perfect. Perfect. Okay, this is the line corresponding to x less than or equal to 4. And what about greater than 4? 31 by 2 is greater than 4. This somewhere is 4. 4 is here. And this is going like this. Please check this out. Is this completely clear? This point is 1 by 8. Tell me. This is 2x equals 1 by 4, x is 1 by 8. Basically, the line is intersecting x-axis at which point is what I have computed mentally only. I've showed you how, but this is how I have computed, and this is my graph. This is my graph of bache f dash. You can see f dash clearly is discontinuous at 4. There is a jump discontinuity. There is a jump discontinuity. So clearly, as I was analyzing and also we had concluded the same thing, but here you can see for yourself, f dash is not continuous at 4 and hence f dash is not differentiable at 4. Okay, so f dash is 100% not differentiable at 4. F dash is not differentiable at 4. It is not differentiable at 4. This is true. That means as an option, it's false. What about f dash 3 plus f dash 5? Let's check. F dash 3 plus f dash 5. F dash 3 plus f dash 5. F dash 3, quickly come. F dash 3 will come from here. So 2 into 3 minus 1 by 4 plus f dash 5 is 8 minus 5. So 6 was a 24 minus 1, 23 by 4 plus 3. So this is 23 plus 12 by 4, which is 35 by 4. 35 by 4 is absolutely correct. This is true. If this is true, that means it's the incorrect option. F is increasing here. F is increasing. For f increasing, I have to analyze the sign change of f dash. So let's go to the graph of f dash. No, let's go quickly to the graph of f dash. You can see corresponding to 1 by 8. If I talk about 1 by 8, everybody please look here. If I talk about 1 by 8, what's happening? Before 1 by 8, f dash is negative. After 1 by 8, f dash is positive. Clearly 1 by 8 is a point of minima. Point of minima for f. Okay. But before 1 by 8, it means the graph is graph of f. This is graph of f dash. Because f dash is negative before 1 by 8, that means graph of f is decreasing before 1 by 8 and increasing after 1 by 8. It is decreasing before 1 by 8 and increasing after 1 by 8. Similarly, if I talk about, in the same manner, if I talk about, let's say 8, right? 8 is another point. After 8, f dash is negative. Before 8, f dash is positive. So this is the point of maxima. Yes or no? So before 8, the graph is increasing. After 8, the graph is decreasing. So if I talk about just increasing, graph for f increasing, it is increasing after 1 by 8 and it is increasing before 8. It is increasing after 1 by 8 and before 8. And where is it decreasing? Before 1 by 8 and after 8. Before 1 by 8 and after 8 it is decreasing. Before 1 by 8 and after 8. Can you see this? Before 1 by 8 and after 8 it is decreasing. This thing is right and that is why the option is wrong. F has a local minima at interval written here is corresponding to actually decreasing, not increasing. That is why C is actually the right answer, because it's speaking the incorrect thing. And F has local minima at x equals 1 by 8 is also true. That means as an option, this is false. I just showed you at 1 by 8 this has local minima, and at 8 this has local maxima. Such a brilliant question, did not involve too much of integral calculus. Just slightly in between, when we were differentiating, we had to use practice. A very quality question which helps you touch concepts from a diverse directions. From diverse directions, you are touching the topic. You are also polishing your conceptual understanding, your very fundamental understanding, which means that you are moving ahead in the game. So a very nice question. I hope every bit of it is crystal clear to you. What have we done? Why have we done? There was a mod inside. There was no need to be scared of it. We had to just break the mod and understand how it behaves. So after 3 how it behaves, before 3 how it behaves, accordingly we have broken down our integral. And after that it was very simple to get the value of b. Once I have b, after that I know the conceptual analysis. If I have my f, I will compute f dash depending upon its left hand limit and right hand method of computing f double dash. Other is studying, which actually gave us a lot of insights about the graph of f as well, or rather the behavior of f as well, that f has local minima at 1 by 8, f has local maxima at 8, where is f increasing, where is f decreasing. So the graph of f dash actually gave us insights about the increasing decreasing nature of even f. So very nice question, yaar, very nice question. I hope you liked it and I hope you've understood every inch of it. Hashtag HDCC everybody. Can I move ahead? C is the right option here. Let's go. Let's go. Tell me, what strikes you when you look at this question? And it requires very basic understanding of differentiation. Very basic. Very basic. And questions like these have occurred in the past way too many times. Just the look of this expression is enough to remind you of the concept required to crush this question. Do you know anybody? Brainstorm, come on, think. Ponder upon it. Try to connect it with something that you already know. You have huge data of knowledge with you guys. You've studied way too much. You've eaten a lot of food. And I hope a big amount of it is digested as well. Yes? So from that chunk, you have to see what this expression is able to connect with. Anything popping up your head? Huh? See, write it down. Write it down. This is f of x minus f of y. And here you have less than equal to 2 times mod x minus y to the power 3 by 2. So it is 1 plus 1 by 2. So I've written it like this. 1 plus 1 by 2, broken it down the very first step. Now this mod x minus y, I will bring it on the left hand side and I will get f of x minus f of y upon x minus y less than equal to 2 times root over mod of x minus y. This is the time where you must realize that your left hand side actually resembles what? F of x minus f of c upon x minus c, as x tends to c is nothing but f dash c. How many of y'all have been able information? If you know it, if you're able to recall it, you will be able to identify that at this stage, this is what I'm going to apply. Just in place of y, there is c, f of x minus f of c upon x minus c. So just apply limit x tends to y, and here also apply limit x tends to y. In place of y, there is c. That's it. That is it. In place of y, there is c. That is it. So limit x tends to y, your right hand side will eventually become 0. Right? But your left hand side will become what? Listen to me carefully. Mod function is a continuous function. Whenever you have a continuous function, limit and a continuous function can always interchange places. So limit and the mod function can interchange places. Limit is allowed to go inside mod because mod is a continuous function. Nobody will explain you with this much detail, but every ounce, every iota of the why ma'am did that should be clear in your head. Okay, so what am I going to get? Mod of, this is limit x tends to y, f of x minus f of y upon x minus y. Is this clear? Less than equal to 0. As I told you, this complete quantity is nothing but f dash y. Its mod is less than or equal to 0. This is true for every y real. Connected? Got it this much? But, so this implies f dash y is 0. Now y and x are just dummy variables. So basically what you are getting is f dash x is 0 for every x real. And what does this mean? If the derivative of a function is 0, that means the function itself is nothing but a constant. So f of x is coming out to be just a k. But it's given in the question that f of 0 is 1. So f of 0, which is k, is given to be 1. That means your function f of x is nothing but 1. It's a constant function 1. So if the question asks you 0 to 1 f square x dx, if f is 1, f square is also 1. 0 to 1, 1 dx, your answer is simply 1, bachche. This is how easy peasy lemon squeezy this question is. Easy peasy lemon squeezy question. Easy peasy lemon squeezy question. Is this clear? The only catch was, the only and only catch was this expression. This is a standard expression reminding you of the definition of f dash c. This. Okay, so the connect has to be established very strongly and very instantly, very quickly. That's when you will sail through the question and complete it within seconds. It's such an easy category question. Okay, I hope it's absolutely clear, guys. Hashtag HDCC in the chat. One more category, conquered, killed. So kind of the questions which I'm sharing with you are itself representatives of